Well, that's different. There we go. Testing the chat. Chat seems to work. Awesome. I have a funny story to start us off in a minute or so. Well, while the team assembles, we'll probably kick off here in another minute or two. That's interesting that usually I get people hopping on Insta almost immediately. But I literally have the opposite. We have the opposite tonight. Hey, Manon. Is it... What did we decide on how to say your name? What do you go by? Menon? Menonania? Yeah, you tell us. Hold on, let me update this. This status. It's a little bit amusing. Yo! Jalisco. Good to see ya. By the way, for some reason, my status thing is not... We've got some internet problems today. So what I'm seeing over here is we've got 16 people on YouTube, which is awesome. But my little control center is... I did make some minor changes to the control center last night. But mostly it was to accelerate the way that it disconnects from the live stream once the stream ends. So it has this plugin now to check to see if OBS is running. And if OBS is not running, you cannot be in live stream mode, since I'm only live streaming from OBS. But in the process of that, it seems as though it's decided to do some other stuff, which, you know, all the things. Let me try something. Ooh, that kind of worked. I mean, not really, but better. All right. Sufficient-ish. I've got a few different... How did you manage to stream Instagram via OBS? Well, it's a little bit tricky. Giovanna? So the way that I do it is I have these restreams. So I use Restream. That might be the first thing to do. And Restream is this site that essentially acts as a funnel to broadcast from OBS to many different places. Let me show you. So here's what's going on right now. You might be able to see some of this since you're on IG, you might not be able to see all this. So basically, what OBS does is OBS does the stream to Restream, and then Restream broadcasts it to TikTok, Twitch, IG, YouTube, and Kick. Yeah, it's pretty sweet. It's great. So if you want to do something similar, check out Restream.io, and there's a plugin for Restream inside of OBS, and then you should be good to go. Now, one more detail that you should know about IG is, yeah, it could be. Yeah, it could very well be that Twitch is demonetizing me, but I don't care. And amusingly, I mean, at least for me, the live streams are not, I'm not looking to really monetize on any of them. I realize that might be strange, since I think a lot of people are. But my goals with the live streams are different. So some of them I think are, yeah, man, it's great. So check it out. And you should check out our Discord, which is also super awesome. I'll drop a link to it. And we just hit 150 people on our Discord today, which I'm super pumped about. You can see in my little, oh, you can't probably see it, Giovanna. Here, let me pull it over. This is mostly because for the IGers, you guys are probably all in just portrait mode, whereas YouTube, Twitch, and Kick are in like full screen mode. But I'll drop the Discord in both places. Awesome. Yeah. And there's the link as well. But yeah, so one of the things we also did, or I just built, so this is a system that I built myself through collab coding with Claude, and it keeps track of stuff. So I mean, part of it is for things related to channels and such, and then there's other stuff in here that's particularly nerdy, like I've got this sort of AI newsfeed thingamabob. Hey Goose, what's going on? Oh, Manon into A's. Mayonnaise. Got it. Mananani. Anyway, once I mentioned my control center here, because at some point I'm going to read open source this system, and it's got like a bunch of different things to it. But basically I'm trying to build this command center that people can use for their own purposes. And awesome. Cool. Let's see if our system, look at that. It already picked you up, Giovanna. So you can see that this system is tracking it, and now we're at 151. Awesome. So anyway, at some point I'm going to open source this. Well, I'm going to open source just the binaries. And the reason for that is I want to do all the code just so I think people have there's some people that have some trust with GTT, that we're kind of doing good things, and I want to make sure that the system is as secure as possible. So I'm not going to open source it in terms of having other contributors, not for this anyway, because this is going to deal with too much sensitive data, and you know, you can bind it to all of your channels. So this is probably helpful for influencers, but I'm also setting up for all the folks on GTT. so they can set it up however they want, and they don't have to have channel stuff, but they can have channel stuff. They can keep track of everything that's going on with GTT. But if you're an influencer, Giovanna, then you might be on these various places. And so this is already set up to keep track. It'll show you where you are currently, how you're doing per day, per week, per month, per year, and then all the stuff. And then there's another, oh, and it switches between online mode and offline mode. Oh, Giovanna, yeah, I'm so glad you chimed in tonight, because you're going to fit in really well in GTT, because a lot of us are in the social space, but we're hardcore technologists. So, for example, Chris, where is Chris? Chris is probably going to join in a second, I'm sure. He's kind of like my left-hand man, and he has like a PhD in neuromorphic computing, and there's just a bunch of like super technical people that are on the GTT community. So as well as basically pretty much all the super nerds that are on YouTube. So a lot of people are finding us from Insta or Kick, surprisingly even TikTok. Like this was pretty surprising to me. I got to be honest. I didn't realize that we would actually have a following on Insta. I mean, I think that's awesome, but we were mostly just doing YouTube at first. This is why the YouTube numbers are like a little more insane. And we just started doing these other ones because we were like, all right, let's just broadcast. Anyway, I'm going to make this available to... Yeah, to be honest, Giovanna, I am a total noob too. I have no idea what I'm doing. I know a little bit more about the technology side. So when it comes to building software systems, hardware systems, code design, AI systems, pretty familiar with that part. But the social media stuff, yeah, I have no idea what I'm doing. I'm just kind of chipping away and slowly trying to figure out all of this madness. So, and what's great about the GTT community is everybody is pretty chill, and we're all kind of learning together. So I think that you'll fit in with our clan, so to speak, pretty well. And there's also people on GTT that know significantly more than I do about social media that are kind of leveling me up and doing awesome things. Oh, that's fantastic. Congratulations. That's really great. Giovanna, how long have you been doing the influencer side? I'm just curious. And I love that you're like a dual class, not to go full nerd, but you know, from a lot of us are Dungeons and Dragons. So you're like a dual class. You're a technologist and you're an influencer at the same time. I love it. Yeah, I think that this is my personal opinion. I guess maybe this is more specific to what we do on GTT, is we kind of need a bigger screen to go down a lot of the rabbit holes that we go down. But I think it's awesome that people are doing the phone like live streams or clips and things. I see quite a few of those. And like people will be on a run or a walk, or I particularly like the ones where they do. Mm, that's awesome. Yeah, and if I can share anything that I've learned, I've only been doing this for, we've only been doing this for maybe a year, little over a year now. And one of the things that I've learned is consistency and just doing content. Content is king. And even stuff that you think, like, honestly, I have no idea what's going to go viral and what's not. And it's kind of crazy. Some of the stuff that I've dropped on for shorts is, oh, yeah, like 100%. Everything that you're saying is super interesting to me because I have no idea about that. Yeah, and Giovanna, you're getting some love from our YouTube folks because they're sending you congratulations on your journey. Interesting. Yeah, I've also found that the clips, the shorts, the reels, whatever the heck they're called, I found that the ones that you can get under 60 seconds tend to be like, they tend to have the chance to go viral. But I gotta tell you, there's some wacky ones that I've done that I didn't expect to go viral at all. And they just like, there's one clip that we did where we were talking about how it's really important to reward people for effort rather than being correct. So rewarding people for engaging and being creative and just trying versus just rewarding them for being right. It's really, I get pretty heated and I'm a very excitable person when I start talking about things that I have strong opinions about, which is almost everything. And I'm wrong all the time. But our Jeter community is helping course correct me constantly. But anyway, so I dropped this clip and it was, I don't know, it was like 2 minutes, I think. And I was just leaning in talking about the things that being right reinforces and the things that reinforcing on effort does. And mhm. I believe, this is my strong conviction, and again, I have no idea what I'm doing. I think the most important thing is being authentic. And from one influencer to another that's also starting out this journey, I think it's very hard at first when you have no following and there's no traction and there's no nothing. And I think it's really easy to get discouraged in the early phases because you're mostly just getting trolled. This is what I've kind of seen. It happened to me quite a bit on YouTube. I was just getting trolled on YouTube constantly. And then when we first got onto Insta, TikTok, and I think it was mostly TikTok and Insta, I was getting trolled like crazy. I mean, it was like 50% or more of the comments were basically, you suck. It was just all about how much I suck. And look, I'll be honest, I definitely suck. I've got lots to learn. But it was a lot of negativity. And I realized that can be very overwhelming for a lot of people when all you're seeing are sort of just negative feedback. And if you can find a way through that and continue to persist, and really, like, not, at least for me, what I tend to do is I just don't really engage with people that are clearly trolling me, but I try really hard to look at every comment and see if I can consider the comment from a positive way. So I try really hard not to make the assumption, hey, Stacy, hey, Labyrinth. I try really hard to not take any of the comments in a negative way unless it's super clear that they're trolling. Because the way I think about it is anytime anyone comments anything, even things that are kind of harsh, one way to look at it is that they care. Because making a comment takes effort. It's work. And if they like really didn't like you, I think there's a much easier way to get rid of you, and that is just to click on the thing and say, don't ever show me this person's content again. Right? And truthfully, I've done that sometimes. If I'm not loving somebody's stuff, just basically don't show me their content anymore. And so then they vanish for forever. But if they engage, one, they could be trolling, but they might not be. They might actually be saying something that could be perceived as trolling, but it really is not that. There's something else going on. And I personally have seen this happen dozens of times, probably over 100 times, where someone has made a comment that at first glance it could be seen as like, you're just being a dick. And then I start talking to him and say, yeah, I can kind of see where you're coming from, but what I kind of meant was this. And then once you have that dialogue, it's really interesting how quick people will flip if they're seen as, if they're seen not just under a negative light. And I do think sometimes one of our hardcore Jeters, one of my inner circle. Actually, I think I got 2 hardcore inner circlers online now on YouTube. And so Sean, Magician, or Magi-Sean, I kind of like Magi-Sean, even though I know he's kind of maybe going for a magician. Just because Magi-Sean is more like, if you go down the deep paths of, not, okay, I'm getting D&D again and all this. Keep in mind, I did create a full D&D video game, right? You guys know this, and so it's hard for me to ever separate. It's no, that's awesome. So this user, complicated user is, I like your content. That's why I'm here. I love it. It's not personal. Don't worry. I think that's awesome. Yeah. And so anyway, Giovanna, I also, I take the same view, is let the haters hate. And then I try very hard to make sure that I never preemptively close the door on people that are making comments until it's absolutely certain that it's clear that they're just trolling. Like that, there's no other way to see it. Yeah. Yeah, absolutely. Yeah, this is something that I try very hard to do, is to look at different perspectives. Because as you guys know, I say this all the time, I'm not the knower of all things. And even if I teach this stuff and I'm married to this stuff and it really matters to me, doesn't necessarily mean that I'm the knower of all the stuff. Like, I try really hard to separate out the fact that I may deeply care about something, but it doesn't mean that I'm an expert in that thing. It just means that I really like that thing. So, for example, I love music. That's why I'm always, rocking out to my music. But I can't play any instrument, not really, and I probably am not super great at creating music. admittedly, I have dabbled quite a bit, and I think you guys have heard some of the, what is it, the Sonos stuff that I've created. But I want to be super clear. Forge uh, on our Discord. Where is Forge? Forge's stuff, in my mind, dominates. I've listened to her stuff. Where is Forge? Oh, is she up to? Okay, Forge better not have left. I'm gonna. Oh, she's just not online. Forge Tracer. This lady dominates with music. This is my strong opinion. I've listened to her stuff. And so anyway, I guess what I'm saying is I think you can absolutely, yes, she's so good. And Sean, I don't know if you've listened to a lot of her stuff, but I think I posted a link in the music channel. Yeah, Forge Tracer. I'm so impressed. And I know some stuff about what she's doing and planning. And I think she's got extreme potential of going major places. Yeah. Oh, and yeah, Giovanna, so learning as we go is how we'll become experts someday. But also remember the quote, Jack of all trades, master of none, is, yeah, the second part is the part that I think a lot of people forget. 1,000 times better than the master of one. Like, a lot of people just remember the first part, you know, Jack of all trades, master of none. And they forget that second part, 1,000 times better than the master of one. 100%. 100%. And that's actually one of our key principles for GTT is growth mindset. Like, if I've achieved anything in my life, it's, I think, probably two major things that I try to do. I think it boils, there's many things, obviously, right? But there's two that, at least from my perspective, that I really hone in on. And okay, that's a little bit, that I'm oversimplifying this. All right, damn it. We're gonna go. I can't. We're doing it. We're gonna go get into this thing. I feel the need to bring up the list. At some point, I'm going to recreate this list just for GTT. I just have been busy or lazy or whatever. All right, I've probably just been a little lazy to do it. There's certain things that I know I need to do, and I'm dragging my feet. All right, I'm going to bring this up. Okay. All right, I'm going to put this front and center here. All right, so as many of you know, I teach CS329M, and right now it's just doing machine programming. We'll probably do deterministic intentfolding next. And by the way, I have some really interesting trying to think of what I can share. There's a really big thing that we're looking at where the customer or the client that we're talking to for deterministic intentfolding is looking to integrate diff into their AI coding systems. And this client is huge. Huge as in, think sovereign country. Think at this level. And then think like, so I'm not allowed to say who this is, but yeah, I think maybe I've said enough already. Probably more than I should have. Anyway, we started these discussions last night. They've been following GTT, and they've been following Merle, and probably, oh sweet, yeah, like the full JB's here now as well. Anyway, I want to show this. In the last lecture that I give for the course that I teach, this is all math nerd, technical mumbo jumbo. But in the second half of this last lecture, I talk about these traits that I think are really important to help people just in general. They're not necessarily specific to technology. They could be anything. You work on anything. And most of the things that I think GTT, our movement, or whatever you want to call it, is we follow a lot of these. Like, we're constantly trying to foster goodwill. So we're starting conversations with people under the premise that they're good people, not under the premise that they're out to manipulate us or take advantage of us or all the thingamabob. Oh, that's awesome. Oh, that's I love it. Yeah, so Giovanna is talking about some of the stuff that's happened with NPM, the Node Package Manager, and how she was predicting a few AI risk events in a row, and was who is CAISI? Is that like a committee for artificial intelligence? Something. The Center for Artificial Intelligence Security. I don't know. I'm guessing. What does that stand for? I love it, by the way. You're teaching me new things. I want to learn all kinds of. Yeah. Absolutely. They're super important. Oh, it's the Canadian AI Safety Institute. Awesome. I love it. Yeah, and Giovanna, if you get a chance, we actually have a few shorts on Insta, TikTok, and others, where we were talking about some of the risks and how the stochastic AIs that we use, they can do bad things when given unfettered access. Essentially, like letting them root your machine. Speaking of which, something that we're going to do, I think maybe Saturday, guys, I'm going to go over just trying to get their name. Oh, it's on the tip of my tongue. Hold on. It's on my dashboard somewhere in here. Hostinger. We're going to go over... Yeah, look, it's yelling at me. See how much I prioritize all of you guys? I need to be doing some of these. Look at this. We finally got a check mark on the data camp one. Woo! Man, that took a little while. Oh, awesome. Oh, by the way, I really would like to, in a completely apolitical way, apolitical way, I would like to talk about the shift that the Trump administration is making toward AI safety. And the reason why I want to talk about this apolitically is, as you guys know, I have a hard rule that we don't talk politics on GTT, because people have different opinions, and all of you are hyper intelligent, and I respect the fact that you have opinions that may be the same or may be different from one another. So I don't want to go down the rabbit holes and have this turn into like a yelling match. But I think that we need to be able to breach topics that are happening at a governmental level for all governments and how they relate to AI. And with this in mind, if we abstract out the current political party that's in charge, okay? Let's just talk about it as there is a political party that's in charge, and we don't need to get into the details of whether we like them, we don't like them, all that stuff. But they're in charge, and they're making certain decisions. Understanding how those decisions impact us, especially related to AI, is super important. That's awesome, Jalisco. Yeah. Yeah, I don't know. That feels like that. I will continue to just advise on the side, as I think you guys know that I currently do, and I'll continue to try to assist from the sidelines as much as possible. Oh, awesome. Yeah, I know about these case guys. Yeah, so Giovanna, one of the things that we did that you, since you're new here, and it's awesome, it's like serendipitous that you are joining and you're here. And by the way, we'll support you and your influencer stuff as well. Like, we're all about community. And there's many influencers that are part of GTT, and we support them as well. Like Cyber Synth Templar, he's doing stuff, and then Sarah Sealine, she's doing a whole bunch of stuff. Yeah, Forge Tracer is doing her music. Just a bunch of different people that do, yeah, we just try to create inclusive community. Anyway, one of the things that we did, Giovanna, is, so while I'm not doing GTT, is I also run an AI company called Merly. And at Merly, we have invented a new type of machine learning. So this is like what I teach at the uni. This is machine programming. And we've invented a new type of machine learning called deterministic intentfolding. And with diff, you can deterministically use AI as a guardrail system to keep stochastic AIs more aligned. So just to be clear, I don't know that you could ever have a stochastic AI be 100% perfectly aligned, because it is stochastic, and stochastic systems are going to behave stochastically. But if you add deterministic AI as a substrate underneath them that act as a verifier or a validation or a fidelity regulator, then you can improve the quality. And you can improve it in a deterministic way that's iteratively refinable. And that's what we've invented with diff, with deterministic intentfolding. And so part of what we're doing, Giovanna, is we're working with some of the very big players in the AI space. I can't really mention a lot of their names, but one of them is we're helping work with Microsoft and GitHub to integrate our deterministic intentfolding AIs into their Azure cloud as a substrate. And there's a bunch of different ways to do this. And we're literally kind of talking to the people that run Azure cloud. And it's great because we're finally to the point in the conversations where they are realizing the limitations in language models, which is incredibly helpful. And for the last 3-4 years that I've been doing Merle, when we first started doing Merle, and keep in mind, I've been doing machine learning for a long, long time. So when we created Merle, we intentionally did not make it based on neural systems or anything that's stochastic, not as the foundational layer, because I had already been down this path. I had been down the path that a lot of people are getting right now, which is, these things are a little crazy, and wow, they're powerful, but boy, can these go off the rails in a major way. So what we've been working on for the last 4 years is essentially inventing new science that allows us to do AI, but in a deterministic way. And the deterministic part, the most important piece of that is it's not even so much the determinism of the inference, or what we call utility. It's more about the determinism that you get from the definition, or the current, what I consider legacy nomenclature of today's AI, is they call this training and iterative refinement, or like continuous learning. I call this refinition. Refinition is the fusion of both model training, so you have a model that's a blank slate, and then you train it one time, the first time, and then it levels it up in some capacity. And then you have n number of subsequent trainings on these systems, mostly to do what is called today like supervised fine-tuning, or in some cases reinforcement learning, continuous learning, something of that nature. But the way I view it is different. I don't view these things as separate. I think it's all the same. I think of it more like how you build software, and that's how I think our AI should be in many cases. And the reason why this is really helpful is when you have software in many cases, not all, is deterministic. And when systems are deterministic, it provides you with qualities like the ability to have repeatability, that gives you interpretability, that gives you understandability, and that can lead to debuggability. When you can debug the AI, I thought we were, yeah, JB, you know me, I'm all over the map, bro. But once you get to debuggability, then that allows you to do iterative refinement. And my strong conviction is iterative refinement is the key to really unlocking the potential of AI. And any system that is not reliably, iteratively refinable, which includes all language models, because they're stochastic systems, you're gonna get a plateau. And I think we're seeing it live. I mean, I'm curious. Let's just do a quick poll. This is largely for the YouTube folks, since there's more of you. Drop a 1 in the chat if you think we've reached a case where some of the language models are plateauing, meaning that it's sort of reaching a point where it's really hard to get these improvements that we've seen historically, and drop a 0 in the chat if you don't think that they're plateauing. And I'm just talking about language models here. I'm not talking about the entire space of AI. I'm specifically not talking about diff, because we know that diff is sort of non-plateauable because of the iterative refinement. That's okay. And thanks, Giovanna. It's super awesome to be chatting with you, and we're super excited about your journey. We'll absolutely help in any way we can. And if you want to get a full more immersive experience and see all the stuff that's on the screen, you are welcome to jump over to YouTube, Twitch, or Kick. but a lot of the crew hangs out on YouTube. Okay, so I'm getting a lot of, let me move this chat over just so some of the other folks can see. Okay, so we're getting a lot of ones. Didn't see, are there any, there's no zeros. Oh, Giovanna, you have moved over. Awesome. Oh, you're in both places maybe. Okay, sweet. Yeah, some people do that too. Okay. There, according to my command center guy, there's 18 of you or 25 of you. Come on. You can chime in. Remember, there's no wrong answer here. I mostly just want to hear what you think. So we've got, again, if you think that language models, just LMs, SLMs, LLMs, what, XLMs, whatever, LM, but basically language models, if they are plateauing, and if you don't think that they're plateauing, drop a 0. So 1 in the chat if they're plateauing, 0 if you don't think they're plateauing. Not talking about all AI. Specifically not talking about diff. Okay. Awesome. Sweet. Seeing a lot of ones, and some people are leaning in even harder, like Magician. Oh no! Oh, sorry. He's leaning a little bit down, so he's 75%. They're plateauing. Stu's at a 50-50. Awesome. User. Ursa's 0.5. Probably way less efficient. So here's my view on this is when we're just talking about language models. So I want to be super clear. I'm not talking about things like using formal solvers, things like SAT solvers, SMT stuff, or neurosymbolic AIs. All of those things use deterministic reasoning, oftentimes through symbolic analysis, which gives you semantics, because neural nets by default don't have semantics built into them. They just do pattern matching. Again, just talking about the neural part, not including anything else. When you complement them with these other systems that have the ability to reason in a semantics or an intentional way, because as we've seen in the pyramid, you know, syntax is the lowest, the next level up is semantics, and the very top is intention. But intention is like, it's the holy grail, but it's the part that's really, really hard to figure out because it's not often said explicitly. You have to reason about, to understand intention, you have to generally reason about actions or behaviors over time to tease out what the intentionality of the thing is. Even if it's intended to be captured like in a specification, what actually happens, like let's just take software. Someone writes a specification that says this is what we're building, and then it goes to the actual building of the thing. It's often the case that what you end up building will drift minorly or majorly from the actual spec. So you can't necessarily just use a specification to tell you the intention, because these things don't tend to stay like in parity. They don't stay in lockstep. So you get drift, right? You have specification and then you get the actual embodiment drift. So this is an example of why intention is much harder than almost anything else. It goes back to the 3 pillars paper, and that's what the second word of deterministic intent folding is that intention part, right? Okay, so my view of this is you can continue to throw more compute at language models, but it's clear to me based on the actions that a lot of the big AI companies are taking that they're starting to suffer so many losses from the extreme compute that's required to do inference, just the inference of the large language models, that they have to start charging you more money. So examples of that: GitHub Copilot turned off basically all the free accounts, many of the student accounts. So getting GitHub Copilot for free. Remember how this all started? GitHub Copilot was free. It was the add-on that everybody got to have access for, and people were loving it up until the point that GitHub was basically like, okay, now there's a paid model, and it's shifted from, oh, this is awesome. Yeah, Giovanna, you're saying some really interesting things. Yeah, so the perceptron learning, right, which predates backpropagation, to the best of my knowledge, was a really interesting way to first understand machine learning in a very simple way. But the problem with the perceptron model is it couldn't, if I recall correctly, it couldn't handle cases that were more nuanced, like XOR, right? I think this was what caused like Hebbian learning. I think, if I'm remembering correctly, and again, I'm just trying to retrieve this from 20 years of it being in my head, because I don't generally think about the perceptron learning. But so it had this problem where it couldn't solve simple cases that humans could, or whatever, like XOR. And I can't remember exactly the details for this, but it caused neural networks to enter like the AI winner until they figured out backprop. And backprop is essentially just a way to think about, or at least this is the way I think about it, to think about the geometric spaces that exist as far as we can, right? This is only for 3 dimensions. When you get into higher order dimensions of machine learning, which many of them get into, like not lowering it down to a latent space that we can reason about, but like this higher order, again, the folding part of diff, the n-dimensional folding and unfolding. Before that, when you are just thinking about a 3-dimensional space, you can think about these manifolds as essentially, the way I think about it is you're playing marble madness, right? And you're trying to find the global minima, so the marble will be at the lowest point. And sometimes the marble gets stuck, you know, in like a local minima, and then you got to jump out of these things. And when you get into all the stochasticity that is inherent in language models or neural networks, it creates this really interesting binding of inability to make reliable iterative refinement progress on them. And the big challenge is that because of that stochasticity, which is inherent because you lose convergent properties on backprop, which is foundational to the learning step for all neural networks, at least to the best of my knowledge today, aside from stuff that predates that, like the perceptron stuff that Giovanna is talking about. That stochasticity is built into the system, and that makes it so the training process, as well as the supervised fine-tuning or the reinforcement learning, unreliable in the sense that you cannot ever guarantee that what you change and what you fix is only changing and fixing the thing that you're intending it to fix. This is like one of the core principles. And because of that, let me bring up one of the like core principles of Merle. This is, and I think some of you guys have seen this because I dropped this on the Discord, is it shows how we think about AI and the inherent pieces that you need to have be part of AI to make it iteratively refinable. Again, keep in mind, iterative refinement is the foundation of the scientific method. It's the core principle that all of today's hard science advances is based off of, is that you have a hypothesis and you're not going to get the hypothesis perfectly correct. It doesn't happen. It's like asking people to write a piece of software and have it basically be your piece of software is perfect and it's done. It doesn't need any changes. That software, in my mind, it doesn't exist. Or if it exists, it's principally because no one's using that software. So the core things that you need, in my opinion, now this is my strong belief, building scientific things for quite some time, and not just the engineering of it, but the foundational science behind it, right? So I'm talking about things like inventing deterministic intent folding and other types of more generalized systems, like inventing the space of neural networks. This is, there can be many embodiments of neural networks. There's many embodiments of deterministic intent folding, right? Anyway, if you look hard, if you look really, really hard at the foundations of advances in hard science, what you will see as a common characteristic for pretty much all of them, not necessarily all of them, but pretty much all of them, is the foundation of determinism. And the reason why you need determinism is so you can do this piece. And this is, to the best of my knowledge, working directly with some of the leaders in the AI space. They're not allowed to say this publicly, but the truth is they're having one hell of a time making their systems better. If just the language model part, it's really tough. They're trying all kinds of things, and they're supervised fine-tuning and integrating neuro-symbolic reasoners into it, or various other types of things. But the foundation of those language models, those things are not deterministic. And that means that this piece right here, the ability to do debugging on these systems, becomes nearly impossible. I'm just talking about the language model. I'm just talking about the neural network, right? So if you want to do AI in a way that gives you the benefits of the hard science advances that we've made historically over the last 100+ years, several hundred years, the core system by itself should be deterministic, because that allows you to do iterative refinement. And if it's iteratively refinable, that's what gets you from the iPhone 1 to the iPhone 16. But if you lose the property of iterative refinement, at what point does the iPhone stop? iPhone 3? iPhone 4? At some point, you get into this plateaued situation simply because it's just a guessing game. And you actually see this. In fact, one of the reasons why I brought this up, I want to see if I can find this. It was actually in my newsfeed. Let me see if I can find this. Oh. Yeah, this one. Yeah, this AI updates. This, I think, tells you almost all you need to know, is that on this page, that I'm starting to monitor is giving you oversight on the various companies doing these AI models. There's something really particular that I have never seen before in like a software system. And that is, let me see if I can find this. They may have removed it. I know that it was on there. Right here. Okay. This part. Models that got worse. Think about this for just 1 second. Like let's meander for a second and let's think about this and try to understand what this means. Think about all the software that you have on your computer. And think about video games that you play or whatever, but just think about it in terms of software. How often have you seen a piece of software, especially going from an iterative refinement? So it's already an established version. It's not a version shift. It is a single version. So let's take Windows 11, or let's take some version of the Linux kernel. How often have you seen that the iterative refinement on that version, that the software gets worse? Now, I know that there are these anomalous cases where they accidentally like drop performance, right, or whatever, but give me, let's do this. Let's do this game. Drop a percentage in the chat that you think is the best approximation that you have on how often you see the software that you're using that stays in the same version. So this is super important because a massive version shift is a different product in many cases. So a very simple way to think about it is think about a video game that you love, like Elden Ring or Cyberpunk or Nautica or whatever, and then ask yourself, how many times is it in the sea of updates? Give me like a percentage, right? So this is exactly what I'm talking about. That is a version change, Colin. That's not what we're talking about. So those version changes, that's a different beast, because it's a different software project. I'm talking within the space of Windows 7. How many times did you see an update to Windows 7 itself make the system worse? Or how many times have you seen an update to Elden Ring, just Elden Ring proper, make Elden Ring worse? And also, I'm not talking about intentional nerfs to the game. I'm talking about the stability of the system, the usability of the system. So give me a percentage of when they do these updates. What is your honest opinion? Try to be as honest, intellectually honest as you can. Is it happening 50% of the time? Is it happening 100% of the time? Is it happening 3% of the time? Right? Yeah, so Windows 11, it could very well be the case that they are actually actively making that worse. I've seen this. And so I would be talking about, like, if you take Apple iOS or take Android, I would be talking about the specific Android version. So we're talking about like Android 12 or whatever it is, not going into Android 13, if that's a thing. And okay, so let me maybe Giovanna is, I might have misarticulated the question, but you guys keep giving answers. I'm super curious. And then I want to try to understand. So what I'm trying to get at here is when they make the updates, are you generally seeing that, like when you say 86%, Giovanna, are you saying that 86% of the time it is an improvement and 14% of the time, 14% of the time it's worse? Is that what you're saying? Or are you saying, because this is actually probably an easier way to talk about it. I think it's easier for, let me rephrase the question, because I think maybe the way that Giovanna is answering it is a better way, but this is a confusing question. So when they do these updates, how often is the update either at parity or making it better? This is a much easier way to think about this. So take your favorite video game, and they do... Okay, I just want to make sure that you're understanding. So you're saying 86% of the time it's worse. Okay, awesome. So let's change the question just because it's easier this way. Let's talk about the percentage of times that it's making it either it stays at parity or it's getting better. And I'm talking about everything under the sun. I'm talking about security, performance, usability, all of the stuff that they're doing. Are they adding more security holes, or are they patching security holes? Are they, absolutely. Are they making it faster? Are they making it slower, right? So if it is an enshittification, which is a totally fair argument, by the way. I think there's a lot of that going on. But I do think that, and you guys are kind of changing my perspective on this, because I can kind of see how it could be different. And then we'll get back to this Gemini thing that we're looking at, where they're talking about the models performing worse. But I'd love to hear other people's thoughts. So the updates in particular, and maybe the way to think about it is this. Don't consider new features. Just consider patches to the system on existing features to make their efficacy better. Yeah, maybe that's the way to think about it. So let's take it like the system doesn't have a really good dictionary, and then they upgrade it, and now the dictionary is better, or actually the dictionary is worse. Or you take Cyberpunk and like it's stalling out and it's just giving you all the jitter. They update it and it's, oh, this is actually better, or it's no, the jittering is worse. What are your guys' thoughts? Like a percentage on this? And it's interesting because I actually can see how this could go both ways, but I have a specific point that I'm trying to make, which I'll get to after we hear more of your guys' thoughts. And by the way, Giovanna, I don't actually disagree with you. Oh, yeah, Colin, right, Colin, that's what I thought you meant. Is I thought you were saying that 14% of the time it's making it worse, and 86% of the time it's at parity or it's getting better. Yeah. Okay. Anybody else want to chime in? Yeah, JB, I hear totally what you're saying. Do you want to give us a number? And I absolutely agree. Like the first version is almost always rushed. And then I generally find that the next few patches almost always make it better. Almost always. Now, when they start adding features, especially features that you don't need, like let's say Windows Recall, you know, when they added that recall thing to Windows 11, and it was just pure enshittification, I think, from my perspective. And then they were like, oh crap, this is really, really bad. It's doing screenshots of like passwords, or it's doing captured text in unprotected log files that are just plain text. Anybody can go in, and now you've actually made the system far more insecure. And then Microsoft realizes, oh crap, we made a boo-boo, and then they pull recall out because it's a terrible idea. Terrible. Or minimally the approach that they had and their lack of care on security is a really big deal. Like, I personally think the Windows recall thing was horrendous. I have really strong opinions about this. I also think that there's no way that should have just been automatically turned on. That should have been an opt-in, not an opt-out. And I think they didn't do it that way. I also think that it's nonsense that Windows, at least at some point, was forcing you to do updates. Like, it would just force those updates to happen. I don't remember if that's been fixed, but I'm on Windows 10 for a variety of reasons. And one of them is I really, really disagree with the principle that you make an update and you have to take that update. Because some of those updates are forcing someone to accept a new security vulnerability. That's nonsense, right? I think the updates always need to be optional. Yeah, right. I think that's a terrible idea. I can see certain cases where there is an extreme vulnerability to the fundamental functioning of the website, and in that case, I could I got distracted. The software where you have a critical problem that you need to fix, and that might be like the 911, where it's like, look, guys, we have to force this. You must take this because we're going to patch something critical. But anything short of that, it should be a choice. Strong claim. I have strong opinions on this. And that's because you don't know what the environment is that the people are using this software. It could be that they cannot allow this system to go down. Like, they're literally running something that's in real time, or it's doing some massive computation. And you can't just take that system offline until the user's ready. Right? Like the Notica server is running on a server in my house, and people are on Notica right now. And so I can do an update to Windows when I properly shut down Notica, but we can't have Windows just coming in, automatically updating the system whenever it feels like it, and shutting down all these things. There's like an order of things, which is why it needs to be like an optional thing. On top of that, there's many pieces of software that rely on certain behaviors of these legacy systems to work properly, and so forcing the patches to be accepted, I think, is not great. Okay. All right, so I think I have 3 numbers now, and I'd really like to hear some more numbers. Is Giovanna is taking a pretty critical view, but I can understand that perspective. Is she's thinking maybe only 14% of the updates are actually making it better. And I think Colin and JB are rolling in around 86% of the updates making it better. Anybody else have any other things? And by the way, everybody's experience is going to be different here. I don't have any kind of like control of the truth. All I have is my own opinion, but there's something really important I want to get to, which should be astonishing to us. And I think that it is becoming astonishing. And I think it's a strong indication that the language models are plateauing. But I want to drag this out a little bit more and hear a couple more people's thoughts. Supposedly, we've got an audience of, let's say, around 25 people. Oh, shit. Sorry, guys. I haven't been monitoring Insta. Hold on. Let me look at Insta real quick to see. Uh, Kyle, Kyle, do you have a number on this that you want to share? Yeah, our attempt of trying to give these. Uh, no. I mean, honestly, Giovanna, we love it. We more care about the engagement, and we're being in trying to create a safe space where people can share their opinions. And I love the fact that you're qualifying this, right? So your experience could very well be that like it's pure enshittification and it's not reliable, whereas Collins and JB's might be different for their experiences. Kyle, do you have anybody on Insta want to jump in and share their thought? So again, the question is, what is the percentage of updates for a particular version of software, any software, where that update does not make it worse? It either makes it better or it stays at parity. And so Kyle is saying that I have no number, but I suspect updates make Microsoft better less than 5% of the time. Awesome. What about things outside of Microsoft or others? Okay, T-Lock is saying, I'd say 10% for me. So he's saying it's like 90% is making it worse. And by the way, I totally can see a way that would maybe make sense in your head, especially this piece, the enshittification part. I see this happen. Okay. All right, cool. So I think we've got some updates or some opinions on this. And I love that everybody went down the rabbit hole of picking on Microsoft. And by the way, if you're like a $3 trillion company and you're supposed to be making the best software in the world, then I think it's fair for people to pick on you, right? Because your software is ubiquitous, right? Just like I think it's fair to pick on Google and Apple, right? Like if that's your primary area and you're kind of making missteps, which I think a lot of us are seeing with some of the stuff that Microsoft is doing, it is getting that. Okay, cool. Now, I have a second question. Along the same lines, give me a percentage too. What is your speculation? What has your experience been? How do you feel about this? That when a software developer tries to fix a bug or claims that they are fixing a bug, what percentage of time do they fix the bug? It's a very different question, right? Now this is specific about a bug. So they have a bug in the software and they're going to go and try to fix this bug. What do you believe, especially as a software developer, the likelihood is that they, when they say, I've fixed this bug, that they have actually fixed this bug? Like they've gone through the regression testing and they've done all this stuff. Like what's the number? So this is a totally different question. Now we're not talking about like if it's making it better or worse. It's just about the bug that they're saying they're fixing. So there was a bug saving the file, and then they say we fixed it, and then it actually saves the file. Or there was a bug where there's this crazy crash, and then they say we fixed this crash bug, and then it turns out they actually did fix the crash bug. Or they didn't fix the crash bug. Like a really simple way of thinking about this is cases for video games or crashes. I think, yeah, this would be a good space of like the P0 bugs. So you've got a P0 bug, priority 0, it's top of the food chain, it's something that must be fixed. And what is the likelihood that when they say they have fixed the bug, that they have actually fixed the bug? What's your speculation on this? Yeah, that that could act that could absolutely be the case. I 100% agree with you, JB. And so since we're talking about like the P0 bugs, that would probably be only the superstars. So we're talking like the principal scientists, the principal engineers, the technical fellows are coming in to fix this critical thing, and then they say they fixed it. Have they fixed it? Okay, so T-Lock is saying, for me, at least in the games I've played, when they say they fixed a bug, they do it. So I would say 85%. And again, now we're just talking about these critical bugs. They MacGyvered it. 100%. Facts. as the kids say. Anybody else want to jump in? Kyle, do you have any thoughts? And by the way, I think it's awesome that you're on IG over here, Kyle. Simply because, so Giovanna's new and she's being integrated into the group very quickly. You're getting a sense of some of the more regulars, and Kyle is superstar for GTT and things with Merle, and it's super unusual for him to be on IG. He must be doing something intense with his computer, I suspect, like working on all kinds of things. Cool. Actually, Kryn, this is a great question for us to dive into once we get done with our P0 thing. So let me circle back to this. I'm actually a command center guy and answer this. Yeah, let's get into this. I was actually talking with a number of people today about the canvas problem. Yeah. Yeah, JB, this is how I kind of think about it too. Actually, this is a good segue for us to drive home the point, and then we can move on to talking about Canvas and many other things. So let me try to springboard off of what JB is saying as someone who's a very senior developer and with lots of experience. Is he's saying, for me, it should pass all tests, and the user marks it as solved, which basically means, if I'm understanding this correctly, is JB is basically saying in cases of like these P0s, when you go to fix it, it passes all the tests, and then the user marks it as solved. It is 100% or near 100% efficacy. You go to fix that bug, and then you fix it. And what's really interesting about this is that notice that JB is referring to these tests that you will run, and you will do basically a walkthrough of trying to repeat the behavior. And there are many factors related to this, but the core point is you can see in a deterministic way, both with the code logically and with the execution through a logical number of steps, that the bug is resolved. And notice that you can do this because software code, the way that it's written today in many cases, are deterministic. So you can logically reason about the code, and this is critical thinking. And essentially what all of us are doing when we're writing code, so we're actually using programming languages to build software. We're not using an AI method to generate a model. In those cases, you can use logic and critical reasoning. And through that logic, you can step through and essentially ascertain that it is correct. And from that lens, under that dimension, what we're doing is, whether you realize it or not, is you're doing a semi-formal method. It's not fully formal because there's, it's kind of a little hand-wavy, especially as you get into points of like if you're walking through the logic in your head, this is semi-formal, whereas if you're using a debugger or you actually do an execution trace, believe it or not, that's actually a formal method. That is formal verification. That is formal verification in a nutshell. Now, one of the things that's super important to understand is you cannot do formal verification on stochastic systems because they're stochastic and you don't know what they're going to do. So even if you walk through the instructions, when you do it once, it doesn't guarantee that that's going to be the outcome the next 99 times. So you can't do what JB is saying. You cannot just run the tests and mark it as solved if you're in a stochastic system, because it could pass all those tests and look good. And then when it's actually used in the real world, decide to be, well, I don't want to do that anymore. I'm going to do something different. And now the answer is wrong. But you only get that in a stochastic system. You don't get that in a deterministic system. And because of that, there is this new thing emerging, which I think is insane, which talks about how the models are getting worse in terms of their efficacy. So we're talking about the accuracy of the model and how it is degrading. And I got to tell you, I don't know any person that's creating software that's intending to make it worse. And I certainly don't think that Google is ever trying to create software that is actually making their software less good. Is with models, the problem that you have is as you're trying to fix the bug, you cannot use logic. You cannot go into a neural network and zoom in on a couple neurons and say, yeah, change that weight from 0.57 to 0.59, and that's going to solve everything, because nobody knows what that means. Nobody knows what these numbers mean. It's just a whole bunch of numbers and a whole bunch of wires. It just does some stuff, but it's a black box to everyone, even when it's not a black box. When you open it up and you can see all the numbers, you still can't make any sense of it, because it is not a logical system. It is a stochastic system. And because of this, what the future is likely to be for stochastic systems is this thing, is there will be a monitoring of these models And we're going to see this. I believe we're going to see this more and more. It's not going to be just about the updates and like, oh, we've got this new update. It's going to be there's been an update and it made the model worse over some set of tests. And what's really interesting about this, guys, is that the set of tests that they're going to run it on, it's not even guaranteed that that's the actual number, because you could run those tests again and they could give you a different answer. So any of the test results that you get for any model, it's when they say like this got a 93% on the whatever the benchmark is that they use for software right now. I can't remember the name of it. It's like bench something. That could absolutely be just a byproduct of this run. Like I don't know exactly how they're calculated. Did they do 10 runs and they just tracked if it ever got the answer right in all 10 runs, and then they combined that together and said, okay, now if you were to overlap that and look at all the times we got it right, there's a 97% score for us, right? We don't know. I mean, that's not how you actually run scientific experiments. The way you do this in the scientific community is if you run 10 runs, you track the efficacy and the standard deviation of each run, and you report on that. So you say on average, it got 70%, and it had a standard error rate or deviation of 10%, which basically means in the lowest case, it got 60%, in the highest case, it got 80% accurate. That's kind of how you run this. But oftentimes what you see the AI companies report on for the models is just a single number. But that doesn't make any sense because they're stochastic systems and they're going to give you these different answers. Now, even if you turn the temperature all the way down, this still doesn't elide away the testing part of the models. That's the core issue. So I don't even care about like trying to get deterministic answers on inference. I care about being able to support iterative refinement, because if you can't support iterative refinement in a way that is predictable, it's not science. That's not science. That is something else. I don't know exactly what that is, but it's not how we do science. We do science using this thing. This is how we do science. It's a systematic empirical process for acquiring knowledge involving observations, hypotheses, blah, blah. And you basically are, you know, again, you're testing the theories, which implies determinism. Because if you can't test them deterministically, are you testing it? Like, what are you actually testing? And this is the major roadblock, in my strong opinion, that language models are suffering now. And it's not for lack of trying. They are doing their best to make these things better. But it's not software code that you can go in and say, oh yeah, here's the bug, let's fix that, and let's just keep cranking. Instead, it is a guessing game. And you get things like adding more data, and you're just crossing your fingers, praying that the more data is going to get you the better answer. But it's not always the case. That new data or the different random weights, there's like so many factors that have nothing to do with its ability to think logically, like how we've done traditional science in the past. So it's my strong conviction that language models, and again, I'm just talking about, so I call them LLMs, language-only models. LLMs have plateaued. Their efficacy has plateaued. And the reason why we're not seeing it in more abundance is they're trying to hide it by fanning the compute out. Because by adding more compute and making the models bigger, they're able to essentially kind of creep along. But now even that's not working. And on top of that, this is not like, if we continue down this path where we get incremental gains on the efficacy, but we create linear or superlinear growth on the compute, right? That's too many CO2 emissions. It's just too much. So, yeah. Anyway, I've beaten this horse. I'm going to stop beating this horse for a moment. We'll take a short break, and then we'll continue. And P.S., I would be happy for us to chat about this question too. Wait, what's happening here? And by the way, I love that, guys. I love that you guys were sharing your honest opinions, and that we went down this crazy rabbit hole. And I actually agree. I think that just going back to the software improvements that are happening from version, I think that from version to version, I do think that there is a true enshittification that's going on, where it's super strange. T-Lock, yeah, thanks, brother. Oh, and by the way, T-Lock, DataCamp is looking into trying to apply that discount for you. So their support team is on it. Anyway, I think that it's one thing to intentionally enshitify the software, like you're doing it on purpose because it's a money grab, and then I think it's an entirely different thing when you're doing the enshitification, but it's because you can't make it better any other way. Like, those are two different things. For example, when Microsoft added the recall, they intentionally did that, which I think was not a great call, and it wasn't super useful, and then they got a bunch of blowback, and then they removed it. But notice that was intentional. It wasn't an accident. They weren't accidentally making it worse. They were intentionally making it worse. Whereas Google over here, I can guarantee you Google is not intentionally making Gemini 2.5 Flash worse. Okay, I can't guarantee you that. I take it back. But I have strong conviction that they are not trying to make it worse. Now, certainly there will be cases where they are going to make the old models worse. You know, this is such a mercenary corporate tactic, but in the future, I suspect this may very well be the case, that as they want you to shift to the newer models, they will do the Apple battery thing, right? Is they will intentionally make the models worse so you will bump them forward. But the problem has changed fundamentally, is that they are out of the driver's seat with stochastic models. They don't have the control that they've had before, where they have intentionally made things worse versus accidentally made things worse. And that's why this is a very dubious way to do science at a foundational level. Foundational. I still want to use language models. Language models are amazing. The advantages that they have are unquestionable, but they also have major, major problems that, if gone unchecked, they can send things in a very serious wrong direction. And we need to be honest about these things. We need to be honest about those weaknesses so we can address them, right? Like, that's the only way that I think we can actually start to improve these language model systems. And one of those is to build in deterministic AI that will complement the stochastic AI. You use them together, right? And deterministic AI just by itself is very limiting. Stochastic AI by itself is also very limiting. But when those two are used together, really interesting things happen. Thus, neurosymbolic AI. Like, that's the whole point of neurosymbolic AI, is it's a fusion of the neural, which is stochastic, and then the symbolism, which is deterministic. The symbolism that's formal logic. That's symbolic and semantic reasoning. Yeah. Yeah, I love that, JB. I think that that is awesome. Okay, let's take a quick 2-3 minute break, and then we're going to go to these other topics and discussions. NSV is the next band-aid on LLMs. What is NSV? Pius? Oh, neurosymbolic verification. Yeah. So I know, I just happen to be really good friends with some of the leading scientists that work on neurosymbolic reasoners or verification. And I think they're cool, but when you use, yeah, there's a reason why we didn't go down the neurosymbolic path and instead did diff. And part of it has to do with the fact that the formal methods approach for semantic reasoning done in a fully formal way, I think is quite limiting. And it's not that it won't get you the right answer. It will. It's just the computational tractability that's associated with it. It becomes exponentially large as you fan out. So, yeah. So user, I think now we're getting to the crux of the problem. This is where we need to start thinking about this. And I think different environments would rely on different types of systems, a different breakdown. And yeah, so Pius, one of the things that diff does is it essentially gives you the advantages of the symbolic reasoners, but it does it at a significant fraction of the cost because it's semi-formal. Anyway, I'll be right back. User, are you on our Discord, my friend? User, all this nonsense? That feels like it's a random word generator or something. Anyway, I love this question and comment. I want to talk about this more because I think this is one of the things we need to be thinking about for the future is for the different domains that we're in, what is the breakdown that we want for these systems? And I think it will change based on where we are in the system building, what the domain is. For example, if you take the starting point of a software project, in the early phases of a software project, before you have users and you're just building things out, you may want something like, I don't know, 80% stochasticity and only 10% determinism. You might even want less than that. So it just goes off the rails and just does a whole bunch of crazy things or whatever. It just like is all over the place. But as that software matures and you start to get users, I think that that shifts significantly. As the software systems become more enterprise ready or they become more production quality, I think that that shift becomes significantly slanted to deterministic outcomes because you can't have the AIs just breaking stuff. You can't build a system that people are going to be able to use reliably and have it just, yeah. And so you can absolutely try to turn the temperature down to 0. That doesn't work, right? It's not, I mean, there's many reasons why we can talk about why that doesn't work. What you really need is you need a deterministic AI that can complement that. That being said, that's like one of the first starts of turning the temperature down. The reason why turning the temperature down to 0 is not necessarily a guaranteed solution to end all stochasticity is that when the LLMs are executing inference in the back end, it can be spread over many machines because the models are too large to run on a single box. And then when you're getting the results, the serial order of those results for a single inference pass could be out of order. When you get out of order results for the inference results, that means that the answer can change. And a bunch of other things, right? Now, if you have a small enough model, like an SLM, that runs on a single node, and you turn the temperature all the way down, you can probably guarantee for certain cases that you will get deterministic output. But you can't rely on this in a general sense. And you don't have to believe me. You can just look at the internet and read all the stuff where people are talking about turning the temperature to 0 doesn't guarantee deterministic inference. But it is a really good first step as you're trying to get things to be more deterministic. But really what you need when you want to have deterministic results is you need a deterministic system. And what's really fascinating about this is I'm very much on the split here, is that without the stochastic ideation of language models, a lot of the massive breakthroughs that we're having are not happening, right? It is super great that the AIs can do reasoning with partial information and they can fill in the gaps. Like, I want to be super clear. This is a technical marvel in my mind, right? The way that I can code and collab code and stuff with this, I'm 100x'd my former self because it can just understand approximately what I'm saying because it's stochastic and it can reason a little bit and work in the gray in this sort of unknown space. And that can be a superpower. But as the thing matures or in certain circumstances, you want AIs that are going to function in a more deterministic way. Like if the AI is flying an airplane. I don't know that you want any stochasticity in there, or maybe you want a small amount just in case like you get unpredictable weather or something. But largely, I think you want something that is going to be deterministically reliable, which is, in many cases, the way that the autopilot systems for airplanes work today, at least based on what I understand. The thing that makes this slightly different, I think, historically from, hey, Dino, a thing that makes this slightly different from traditional rules-based systems that are all deterministic is that you can build AI systems that are also deterministic. And then this allows you to essentially build rules, but they're learned. And that is allowing you to essentially create a system that will scale with significantly more knowledge than you'd be able to do than if you wrote the rules yourself. Does that make sense? Right? It's sort of like you can still use AI. So I think that one of the superpowers of AI is the ability to learn from an enormous corpora of data. Right? That's kind of the fundamental, in my mind, that's the fundamental difference between learned systems and heuristic systems. Heuristic systems are essentially, we have an idea on how to solve this through human knowledge, and then we know what the rules are, so we write them down, and then that's our heuristic, and it works, right? The problem with this is limited just to human knowledge, or what we know. But there's a lot of things that exist in the world that we haven't considered. So then you can have essentially the learned system that can do a very similar thing. If it's deterministic, it can essentially create that same heuristic that's rules-based. But rather than using just a single mind of knowledge, it can learn from this enormous corpora of data. And from there, it can likely come up with better heuristics because it just has more data. And that's actually what we've done. That's kind of the way to think about Mentor. And the other thing that is really awesome about diff is when diff is done properly, it has deterministic, interpretable, and debuggable models. So if diff does something wrong, you just go in and change the model. You can manually go in and say, change that, you're wrong. Mentor, you're wrong. The right answer is this. And you can go into the spot where it's making the wrong decision and change just that. Just the one thing. That's right. It is not a black box at all. It's a complete white box. And what you're changing, it's not code. It's like something different. It's hard to kind of explain what it is. But it's basically, like the simplest way to think about it is as an anomaly detection system, and then the thing that it's flagged as anomalous is either right or wrong. And so you can go into the table that has the generalized representation of the anomalies, and then look at its abstract representation and say, oh, you've got the wrong value here. It's this. And then it's changed. And now the only thing that you've changed is the one thing that you intended to change. Nothing else changes. And therefore, you have iterative refinement. And once you have iterative refinement, guys, like the sky's wide open. Especially when you have iteratively refinable AI. Because now you get kind of the best of both worlds, right? Is you get an AI system that can learn from enormous data. That's not possible without AI. But you don't have the drawback of it being, I don't know what this is, I don't know how it's going to work, and it may go off the rails. Like that part is gone. So what we're working on, for example, with some of these big AI developers is integrating diff at the substrate level, which basically a lot of them have come to the same conclusion that we came to 4 years ago. And again, this isn't I'm not trying to knock them at all. It's just we've been doing this for a very, very long time. And so it's like a little more obvious to us that this was going to be a problem. And so we were working on this since, well, I mean, in my head, I've been trying to figure this out for 10 years, for like a decade. And I think that we have figured, like there's tons of more things to figure out, but diff works. And it's deterministic, and it's fully learned, and it can reason about intention, and it has the ability to understand semantics, and it supports dimensional folding and unfolding. The real key thing with the folding is the ability to explore higher order dimensions, not just latent spaces. Like this exploration of just latent spaces, while I understand the benefit of it because it simplifies things and the compute becomes faster, all that nonsense, 100%. But like, there is richness in detail that I believe can only be observed in higher order dimensions, especially the ones that exist outside of the dimensions that we live in. Like, and this is a very hard thing to understand because most of us can't think, we can't even reason about dimensionality beyond 3 dimensions or maybe 4 dimensions, but that doesn't mean that those dimensions don't exist, right? Again, the example that I use is infrared. We didn't know infrared existed for a very long time until we had infrared sensors. And then we're like, oh, infrared. Awesome. Okay, hold on. Let me look at some of the comments here. Yeah. JB, 100%. And what's interesting, though, is I'm at the point where I'm not super interested in this, of people throwing us money. I'm more interested in building the systems with the technology that we can, like we already have, and having them give us money for the product that actually provides value. Because whenever you take money from investors, there are always strings. And some of those strings are really not great strings. It depends on the partner, right? So, but as they say in the real world, there's no free lunch. But yes, I think a lot of people would absolutely do that, JB. In fact, there are many people that are doing that. Yeah, Giovanna, that's why large companies who were after profit went stochastic first. A big reason why they did it, Giovanna, to my understanding, is language models already existed. So what they did is they had transformers because they're really good at natural language. And it was just like, what could we use these for other than natural language? How could we repurpose the technology that already exists? So essentially, what can we do without really trying? It's not going to take a lot of effort. It's not going to take a lot of money. And we can use the stuff that already exists. It makes sense if you're just thinking about money. You're just thinking about, like, can't we just reuse these natural language models for programming language models and other stuff? And then it's like, kinda, we can. And then it kinda works. And then you kind of go from there. So, okay. The issue on fully deterministic AI is that it would not be as marketable, profitable as stochastic AIs because we have a vast array of users and they all have different brains and personalities. This is actually a really interesting take, right? So I don't know that I fully agree with this take, Giovanna, but one, I have to say, I really appreciate your courage to speak your mind. I love that. I think that is super awesome. Is you have ideas on things and you're gonna share. I love it. Seriously, it takes a lot of courage to jump in with the GTT crowd, many of which are in the 190 IQ range, that are deep experts in some of this stuff. And yeah, So I love it. Please keep doing that. That said, I think it really depends on what the goal is. So, for example, I see it as a very nuanced space that is very hybrid oriented. That I think of it, I've got a slide on this somewhere. I think we went down the path of looking at, hold on, give me a second to find this slide that I think captures. Oh, wait a second. Before I do this, Pius, you had a question? How do we solve the context problem? Are you talking about the, Pius, are you talking about the context death spiral? Pius, are you talking about the context death spiral thing? Where it's like, you, like in the, yes, okay, the death spiral, okay. I have an idea on how that we can solve this. Or at least I have the beginnings of an idea on how to solve it. And honestly, guys, I'm solving it with this. This is an example of me solving it. Because you guys have seen this. This app is getting progressively better and better, right? Over the last several weeks. It's not getting worse. Now, it's not to say that I haven't run into issues. I have. But as you guys can see, like, if I still have some redraw issues that Claude and I are working out. Okay, here, we'll do this. Okay, so let me just walk through. So you've got all these various different channels or pages. And so I've got the news page. And by the way, I've got the news feed. But keep in mind, this is different than an RSS feed because this is stochastic. And this actually goes back to Giovanna's point, is I like that this is stochastic. I prefer this being stochastic because it takes us beyond what is possible with normal RSS feeds. The normal RSS feeds are just going to give you a slotted range of news that you specifically determined a priori, but there are things that you may not know about. And if you're only reading from these specific news sources, you would miss them. So the way that my thing is set up is it has 3 sections. It has the most important news of the week. By the way, this is not very well organized, but I'll clean this up. So the first section is this is the hottest news for the week. The second section is yesterday's news in case I missed stuff, and then the bottom is today's news. So this is essentially the sections. And anyway, the point of this is that as I'm working on this system, it's just getting better, essentially. You're not seeing that it's like devolving or running away from itself. And I'm getting more and more features. And the way that I'm doing this, the thing that I figured out is the key piece that you really have to lean in on to get the AIs to build software in a really good way is you have to guide their design. You must. You must help them understand how to design software, and you need to keep an eye on this the whole time, because if you don't, then they will essentially devolve into the context death spiral, and things will get so chaotic and just bad that it'll become spaghetti code. So one of the things that I'm doing is I do refactors of things constantly. And so I'm guiding it on all the things it needs to do in terms of what the design actually needs to look like. And hold on a second. Why is it that I can just be at 50 or 100%? That is crazy. Okay. Anyway, you don't really need to see the details of this, but what's important is that I'm working on the design with Claude and it needs help with the design, because if left to its own devices and it's just writing code, then it goes totally off the rails and you end up with spaghetti code. But if you constantly are redirecting it to help it iterate on the design, and I've had to do this many, many times, have it take a step back and say, no, you're designing this the wrong way. It needs to be designed like this. And I'll give it guidance and I'll say, now apply this thought process to the entire software and then create the design diagram for me so I can look at it and then we can iterate. What happens, or at least what I've seen happen, is first it simplifies the logic like tenfold or something like that. Is you don't get into what we saw with the ClickHouse. You don't get the ClickHouse if-else explosion, which is completely unmaintainable code. And by the way, that's the direction they're going to go in. I've had to train them. I have rules now in place that tell it that it cannot do certain things, and it has to follow these rules. And I didn't know exactly what those rules were until I started working with it and seeing the bad things that it was doing, right? So there's many things that it was doing that were like really, really bad. What's my view on Devin? Yeah, great question. We'll get to that in a second. Yeah, Cognition Labs. Lots of thoughts. Didn't love the way that they started, but maybe they're doing better now. Anyway, so in terms of answering your question, Pius, and I'll circle back to this, Giovanna. The way that I am getting past the context death spiral is I have these rules that it must follow, and I am forcing it to follow certain key design principles that it didn't want to follow, because keep in mind, the AIs by default, they're going to, in many cases, take the shortest path that they can. It's a least effort problem, right? It's going to be the least amount of effort to answer the question or to do what is being asked, even if that is the wrong answer long term. For example, when I would ask it to do something, like I would say, you need to widen this frame here, so like things don't roll over or whatever. Or I would say, here's maybe a better example, is I was trying to make this editor like a normal, like a legit editor. And so I wanted the behavior of a real editor. I wanted it to be able to highlight things and then to do the normal things like copy and then paste, right? Which it can do now. And I wanted it to do like, one of the things that I do a lot is I do this control delete thing where I delete words at a time. I don't generally I don't delete things like this. I tend to do this kind of thing, and then I'll rewrite something, right? So anyway, all of this stuff that I was asking it to do, what it was doing, as a concrete example of how you get to the context death spiral, is it was coding each of the things one at a time as individual cases, rather than solving the general problem of adding like hotkey power user behavior. So it was a one-off every time. It was like it started to build this big if-else tree. If they press this control thing, blah, blah, blah. And it was all in the code. And I was like, stop. This is totally wrong. This is not how you do this. And I was like, look, here's how you do this. you have a JSON file that is a mapping of the characters that you press and then the behavior that it should take. And then you read in this dictionary. Then when the user presses the commands, you do a lookup on the dictionary and then call into the associated function. This change, very simple change, right, got it to, one, create a significantly more decoupled system that's still very cohesive. It pulled out all the resources out of the code because it was hard coding everything as it does, which is one of my biggest qualms, because hard-coded code, hard-coded literals, hard-coded strings, you can't build highly extensible software using hard-coded literals. You cannot be done. You have to have a separation between data and control. And by default, it's not going to do this for you. It's going to put them together and your life is going to suck because it can't do the dictionary lookup. Keep in mind, like my change, just this simple design change, it changes it to a lookup on a dictionary, which is a mapping. It's a map jump, right? Because it's trying to do, here's the key. It does a jump into the map. Either it does a hit and finds the location, or it's a miss, and then it throws an exception or whatever, but it's caught. And then if it works, then it just calls the function. That behavior is not even an if else, not in the code. In the code, it's just it's a table function call. Jump to this location of the table, execute the function that's associated with it. Now what this has done is that any new commands that I want to add to this input guy, I just say, oh, you forgot this command. What it does is it just updates the JSON file. So literally, I can have updatable functionality for this input window with 0 changes to the code. And so instead of getting that massive C that we saw, and it's just getting bigger and bigger every time, it's one line of code. And that one line of code never changes. This significantly shrinks the context that it needs to reason about to figure out what to do next. It doesn't have to reason about the code at all. Now all it has to do is just manage a JSON file. So one of the things that I've learned that is principally important to make this work is you must drive the design of the AI coding assistants and focus. So you have to do two things, I think, in order for them not to veer off into the context death spiral. And for those of you that are not initiated to the context death spiral, what happens is if you get the context death spiral happening where you have too much code because it's been slop coding, it's been doing its stupid vibe coding thing, which is not at all what I do. Mine is all collab coding, right? Because I'm looking at the code. In order for me to give it guidance, I have to see the code. And then even though I'm not writing the code, I don't need to do that. I just need to know the crappy code that it's writing and then fix that direction. So you can't vibe code this. You can't just say, do this thing and just never look at the code. You must look at the code. It doesn't mean that you have to write the code, though. And so there's some amount of understanding code, but look, let's be honest. Like, you can get a general sense of code without knowing the programming language, right? You understand certain core concepts, like what a for loop is, if-else stuff, what a class is, what a function is, right? You don't need to know all of the specific details of the syntax. Oh, that's awesome, Giovanna. Yeah. So this is the strong difference that I have on collab coding versus vibe coding. Collab coding, guys, it fucking works. It works. I am building this software system, and this is turning into production quality, enterprise grade software. It took me some time to figure out all the things it was doing wrong, but I can show you how to do this. And there's two fundamental things that you have to do, is that you have to be able to be very clear in what you're directing the AI to do and try to explain it in a generalized sense. So you're not trying to solve the specific thing, you're trying to solve a general problem. That's one of the most important things, because if you tell the AIs to do this specific thing, they will do just that specific thing. But if you say, look, you're going to build this thing in a generalized way, I'm going to give you 2 examples, and then you're going to go learn all the other things and build in all the other things that I'm not mentioning here. And so I literally will send it into planning mode. I'll send Claude into planning mode and say, all right, you have to plan this out. And I'll literally tell it how long it's going to take. Because if I don't say, you need to do 2 hours of work here, you cannot do this in 5 minutes. If I don't actually instruct it to do this, it literally will try to do a 2-hour task. And I'm talking AI 2 hour, right? It'd take a human maybe 20 hours. It will try to do it in 5 minutes, and it will do it in 5 minutes, but it will be total garbage. It will be complete nonsense that's completely wrong and has to be done entirely again. And so anyway, yeah, so there are 3 things. There are 3 things that I found that seem to work really well, at least with Claude. And I'm using Opus 4.7 or something, and I'm on the max user plan, so I don't even think I have a token limit. Although I will tell you that at 1 million tokens, something happens. Like, I think it restarts itself and has to re-pull in the context. So again, part of the reason why you do this, so you don't have to keep redoing the context, right? The goal is to keep the code as streamlined and small as possible, and then separate things out into really small components that have functionally disjoint properties. But you have to figure this out, because at least right now, the AIs are not smart enough to do this, or they're too lazy, or they're just going to get it wrong. Right? Just keep in mind that the AI is the super intelligent system that is extremely lazy. And anytime it can take a shortcut to get the answer like faster, it's going to do that. So you have to literally say, no, AI, you have to go slow here. You have to go do all these steps, because if you don't learn about this first, you'll do like the wrong thing. Okay. So the 3 things that I've learned right now for cloud coding to make it work. Thing number 1, you have to explain what you're trying to build in a very general sense. You give it 1 or 2 examples, and then you tell it, generalize this and go learn about this. So go read up about it, and you can give it an app or something that it should follow that already models this. Like, I think what I did is I said, model this based off of VS Code's editor. And then I pointed it to VS Code, the VS Code repo. So like, all it has to do is just read through the repo and learn about stuff and then figure things out. And like, I could have told it, base this off of Microsoft Word, but the problem is that's closed source. And so what I'm trying to do is I'm trying to help it as much as possible so it'll get the right answer. Okay, that's step 1. Step 2 is you have to constantly be involved in the adaptation of the system. Sorry, no, that's step, that's step 2. And that adaptation is you are continuing to evolve the system design, right? Like this thing is you need to get it to draw the pictures for you. This is where looking at the code by itself is not sufficient, because, okay, you could figure this out from the code, but it's much easier for the system to just draw it for you. Is you say, okay, look, draw out the major components that you have in the system so I have an understanding of how this works and I can help you revise this. This part is super important, at least it's been for me, to help me understand where it's doing really dumb things and then course correcting it and making sure that it has all the right stuff. And at least for Claude, it's very easy for us to do this. So you'll see it has certain things that I've taught it that it needs to be able to do. Like adding a new platform is as easy as dropping this additional JSON file, no code changes. So I can say, okay, now add this new platform here, and it can add it without making any code changes, which it should be able to. It should be able to do, right? Like this is not rocket science. It basically is how I would design it, is I would design this as a generic infrastructure where it is essentially a social media source map, and it has a name, and then in the name it has a data structure that tells me all about it. It tells me like what the general URL is. It tells me, I don't know, a whole bunch of other things. In the case of social media influencers, it's going to be things like your username and like your channel name and all this stuff. But notice that if you do this properly, you write the code in a very generic way, and then you add new channels that are completely separate from the code. So I had to guide it on this design. When I first was doing this, it was just adding this all into the code, right? It was just adding, there were blocks of code where it was like, okay, here's Instagram. Like if Instagram, do this. If YouTube, what are you doing? Right? Like there should never be a literal string in the code ever. Everything is based off of variables. All the literal strings are in resource files. By the way, this is also really important if you want to go multilingual. And I realized that at first glance, you like, well, that's a big step. But if we want to build real production quality stuff, we should consider localization problems, like supporting Japanese or German or whatever. That's another beauty of abstracting these out, is that the way this is designed now is essentially all of the visualization, all of these strings can be rewritten externally in the JSON files without changing a single line of code. So it will be localized to a completely different language. That it's now showing you German, or it's showing you, Japanese, or whatever the heck you want it to show. Okay, so that's the second piece, is you have to guide it on the design. If you don't guide it on the design, my experience has been you're gonna get a vibe-coded spaghetti nonsense, and you will reach a point of the context death spiral, and literally you're cooked. You're cooked for a variety of reasons. It's too much code to reason about to do really simple things. And a lot of people are doing it this way, and it's making it impossible for them to make even the simplest updates to their software because they're vibe coding. They're just saying, do this, do this, do this, do this, and then it's just adding the stuff, and you get total garbage code. And then the major challenge with the context death spiral is once you get into it, because there's so much context to reason about, the quality of the AI gets worse. What happens is it's not just that you're burning through more tokens, right? That is part of it. The other part is it loses the ability to actually do meaningful work because it's slop coded its way into this state of complete and utter stupidity. And if you don't specifically keep it on the rails, even with the best AIs, they are gonna do this. At least that's been what I've seen with Claude Code. Awesome. Yeah, absolutely. Now, the third thing so again, step one, general purpose instructions with a couple examples and sources that it can learn from. Super effective. Step 2, you must guide the design, and you need to look at the code to see where it's going off the rails with the design, and then course correct it and make it fix that code. Specifically ensuring that all data is not in the source code. They're in resource files. If you don't explicitly tell it this, it's going to make your code suck. And it's going to make your app basically come to a screaming halt. Then the third piece is you have to do this in iteration. You have to iteratively refine over and over those 2 steps. And even in the same cycle. So when I was... Yeah, and absolutely, like once they start to spiral, you are left with basically an AI that is massively handicapped. And it's not that the AI is actually handicapped. I want to be super clear. The AI is fine, right? It's that it has too much context that it has to reason about because the code is so shitty that it can't make the right decisions anymore because it exceeds the context window. Right? Exactly. Yeah, we do need to figure that out, and I don't know exactly how. I mean, the way that I was doing this in the past, JB, is I was doing this thing called meta prompting. And so the meta prompting was essentially giving it guidance on higher level things where then it was able to create more elaborate information that's actually sent to the LLM on these things. But I need to take another look at this to see where we are with the state of these things. Yeah. So that's my high level advice on how to deal with the AIs to be able to build actual production quality code with them. And guys, I want to be super clear. You can build production quality code with the AIs that exist today if you follow these 2 principles. But you have to be hyper vigilant, and it is going to make you slower initially because it's going to, at least my experience is, it doesn't get it right on the first try. Is I'll say, remove all the strings from the code, put them in resource files. And then it'll say, okay, done. I've removed all the strings. And I'll be like, okay, now do a scan of the code and show me lines of code that include literals. And it does this task, and there are a whole bunch of literals that it finds. And I'm like, okay, you just said that you removed all the literals from the code, but in your scan, you clearly did not. And what's awesome about the AIs is they generally are understanding their own kind of silliness. So as soon as you ask them the second time, they'll be like, oh, I got that wrong. I need to do a better job of this. It's like, yes, you do. I'm not kidding. And so this was a learning experience for me because, and again, this is part of the stochastic piece that you got to kind of deal with, is that they're not going to do what you ask them to do right out of the gate. It's an unfortunate thing, and I don't know exactly how to solve it, but what I've seen is that as long as you nip things in the bud soon, the ability for them to do that with like more efficacy increases. So part of the reason why this took a little while at first is I didn't realize that I wasn't looking at the code. I was in early framework setup, and I was just cranking on the general design of things. And so I didn't look at the code until I had the first whole pass. And at that point, there were already like 5,000 lines of code or something. And so there was a whole slew of things that I had to fix. If I would have been more on top of that, then it probably wouldn't have been so bad. Yeah, and I do think that you like, okay, so what I'm trying to do here is there's this really interesting mixture of people on GTT. I think we're hitting the whole full spectrum, right? Which I wasn't expecting to happen, but I love. Is you have people on the very far end that are the super experts, like Chris Roy, who's a PhD. He's written, I don't know, hundreds of thousands, maybe millions of lines of code. This guy's a superstar and can do basically whatever he wants. And then he's using AI to just do more stuff. And then on the other end of the spectrum, you have the beginners that love the idea of being able to create software, and they know nothing about code, but they know that the AIs can code, and so they want to use that. So now on GTT, we have the whole spectrum. We have the total noobs that have no background in this at all that we need to help. And then you've got the power users that are like PhD level superstars that want help as well, but they require very different help. Okay, so what I just described in the first pass is more about the experts. What I explained about the 3 steps is expert level PhD. I'm a principal AI engineer, and now you know the key things to just crank it up with the AIs to stop the context death spiral. All right, so now let's pivot the conversation and go to the other end of the spectrum, where Kryn is. And I want to try to help him because there is a large majority of people that are in that space, and there are easy things that you can do, Kryn, that will help you get kickstarted on this, and you'll be able to chip away and actually use the AIs to build code. But I want to be clear is that, as I think Giovanna said, this is really important, is to try to learn. Again, we want to be super empathetic to people using AIs to create software. This is one of the most empowering, democratizing technologies in the world that for the longest time we've been the 1%. Those of us that can read and write code, we run the planet. I mean, look, it's just this. That's just the state of things, right? And anybody that can't read and write code, it's closed off to them. It's a literacy thing. But now with AI, it's democratizing the space, and that's really good because there are a lot of people that are super geniuses that just don't know how to read and write code, but they're not dumb. They're hyper intelligent. This is just not a skill that they've developed. So now what is the path that people like Kryn or new people that might be hyper intelligent can take to start building a software? Okay, the easiest path that I can think of, yeah, the back end 100%, and the back end stuff is and I don't mean to make all the front end people angry or create a holy war or anything, but look, if the back end stuff doesn't work perfectly, you're cooked, you're done. Whereas if the front end doesn't work perfectly, like, you might just have a single user that doesn't have a perfect experience. If the back end isn't working brilliantly, every user is hosed. Okay, so Kryn, what I would say is, this is my strong conviction, is you probably need to understand some of the primitives of programming just so you can look at code and get an intuition of what it's doing. Now, you don't need to be able to actually write code to do this. All you need to do is be able to read and pattern match. And yeah, Dark, absolutely. And I love that you just mentioned this. I take that as you volunteering to flesh out this path, or you organizing a team of Jeters to do this. And so I love it. You now are the boss of this thing. And you're absolutely right. We 100% need to have a document or something that is going to help the newbies get some value from this. And so in my head, without having thought about this deeply, is I think that you need to understand a little bit of the core concepts of code, so you can just look at code without fully understanding it and see sections. And you can see like this section of, oh, this is a function. You see another section is, oh, this is a class. See another section be like, oh, this is an if-else block. See another section be like, this is a switch, right? And again, you don't need to know all the details. It's quite strange because it's yeah. The truth is, Colin, actually, in almost all cases, this is, I think, the right way to teach things. And the reason for this is that when even I will teach this way, is if I try to teach the theory of machine programming and ML and diff, I'm losing a majority of my audience. It's just really hard to follow. So instead, what I try to do is I teach concrete examples of like, you could use it like this and like this. And then once they get in their head, like, oh, that's how that could work, then I take a step back and say, okay, now the actual theory behind this, like for example, with diff, I think everybody got the cases of here are the 3 ways that you could use diff with language models. You use it as a pruning system for LLMs, you use it for in-flight training of the model, and then you use it as a backward edge verification system of LLM inference. Notice, though, that in those cases, I haven't explained what diff is at all. I've just explained how you could use it. And so now what people have in their head is like, oh, okay, I don't know what this diff thing is, but I know that it could be used to make the data that's coming in better, so the model will be better. So it acts as a pruning system. The second piece is I could use it to help improve the actual model training itself. It's going to improve the fidelity. And then the third is that if the model is already trained, I can use it to send bad inference results back and have it fix those things, so then the overall inference efficacy is improved. Yeah, and zero jargon. It's so hard to do this, especially for like the hyper nerds, because we say things like inference, backpropagation, stochastic gradient descent, deterministic intentfolding, right? Template metaprogramming. We say these words not to sound clever, but because that's the name of the thing. The problem is that those words don't mean anything to people that don't already know that jargon. So you have to try to explain it in ways that are like, explain it like you're explaining it to a 5-year-old. Or, what is this? Explain it like you're explaining it to a 5th grader. Something like this. Anyway, so Crin, the way that I would approach this is, if you're new to all of this, the first thing is just try to get a sense of some of the core concepts that are in the programming language that it's going to build itself in. And that's probably going to be like Python. It might want to do it in JavaScript, which I think is maybe not a good idea unless it's absolutely necessary. Python can be not bad. Doing it in Go this is all Go based now. Go has a lot of good principles in it, I think, to build production quality software, but it also is not overly complicated like C++. And as you guys know, like C++ is my stomping ground. It's my favorite programming language, but it's very complicated. And there are times where you need to go like full C++ if you need to make things like screaming fast or whatever. But in many cases, you don't need that type of sort of like nuclear level strength. You can use a simpler programming language. Anyway, so I would start with that, Kryn, and you don't need to know all of the syntax for the whole language. You just need to know some of the core concepts. And the reason why this is important is then you'll be able to look at code and do pattern matching. You'll be able to say, oh, that's a class. Oh, that's a switch statement. I know what a switch is. It does this thing. And then from that, you will likely be able to tell if things are getting like off the rails. I mean, probably not to the level that someone like Kyle can, or Pius, or JB, people that have been working in this space for 15, 20 years. And like that's all in just the learning, right? So that's sort of a fair breakdown. Is it would be unreasonable to think that you would be able to look at the code the same way that they can, but you don't need to understand all of it. And the truth is, if we're being honest about this, guys, whenever we look at code, none of us ever really understand all of it. We get a general sense of it. Like we see that there are function calls and we know intuitively like, oh, I know what this function does, but we don't know exactly how it does it because many of those details are not important. What matters is that it's doing a thing, not necessarily how it's doing that thing. So it's the same thing here, Kryn, is that you don't need to know all the details of this thing. You just need to get a general sense of like how it's organizing stuff. And then like, so that's the first piece, because then you can start looking at the code. And my hope is that you would be able to see if it's starting to do some like egregiously bad things. Like if you see an if statement that's 500 lines long, right? That might send a little bit of a red flag of like, why is that so big? Just kind of like if you think about writing, right? If you were to see a paragraph that is 100 sentences long, most of us, even not super seasoned writers, would kind of look at that and say, I don't think that's right. I don't think paragraphs are supposed to be that big. So this kind of thing, it's meant to just give you an intuition. The second piece that I think is critical is to think about designing the software so that the components are small and easy to separate. Now, this is a very advanced software engineering thing, and so you're not likely to understand this like right out of the gate. But the way to think about it is any particular task of the software should or could be like its own module. So, for example, if you had an app that you're building that's going to read in a whole bunch of data from files, you might have a system that is your file management, right? And that's just a natural thing of just saying, well, there's a part of this where it has to read a whole bunch of files and then write the files. So maybe there should be like a file management component. And notice too, this is something that I think a normal human being would be able to intuit as long as they have the ability to think critically. The most important thing, I think, for all of us moving forward is my strong conviction, and this is what I've been preaching at the university for some time, is that you focus on strengthening your critical reasoning skills. Critical reasoning is going to be super important no matter what happens in the AI future. This is my strong conviction. So even if we're not writing code, our ability to think critically is going to help us design the software while the AIs write the code. If we're using the AIs, Michael, oh, sorry, I thought you were referencing the 3 pillars of machine programming. So along those lines, the 3 pillars of machine programming, one of them is intent. It breaks it down into intention, invention, and adaptation. And I think we're starting to see that breakdown happening live now. Is that now the way that we are building these systems, in fact, very much like how I am collab coding, is I'm doing just this. The first part, notice like if we take the 3 pieces that I was just describing, the first piece is intention. I'm describing my intention. The second piece is the invention. I am explaining the components that should be used to build this thing. The third piece is adaptation. I'm now saying, okay, we have to iteratively refine this to make this significantly better. So I feel like the 3 pillars of machine programming is becoming real in real time. Like, I think we're doing it as literally as we speak. Okay, so Kryn, going back to what you could do is, again, understand very simple syntax, just so you can look at the code for pattern matching. Not that you need to understand it. It's high-level abstract generalization. Second is think in your head in a critical way. What would I need as like components to build the stuff? And you will likely come to conclusions on, oh, I need a file management system. Oh, I need some sort of display system. And you'll probably start, I think, at a very high level. And then as you get more experience, you'll likely be able to drill down and break them into these smaller buckets. And the smaller is generally better, especially for AIs, because too much stuff in any one of these components is likely going to cause it to have the context death spiral. And then just do that over and over. And then, sorry, the last thing that I would recommend is to read design principle books. The most important thing I think moving forward with AI collab coding is design principles. That's my strong conviction. Is the coding part is going to matter less and less because the AIs can handle a lot of that. But what the AIs can't do without guidance is proper design. They're not super great at doing this on their own, at least today, based on what I've seen. And so you guiding it on proper design is very helpful, I think. And I would argue that that would lead us to read design principle books. And the one that comes to mind is, you know, the Gang of Four. I forget. Gang of Four design. Yeah, this design patterns book. Yeah, this one. Design patterns, elements of reusable object-oriented software. There are many that I've read in my life, but this one is pretty good, I think. There's a bunch of things that they talk about, and they're very pragmatic. And many of the systems that you're going to build today, they're going to be object-oriented. If it's in Python or JavaScript or C++ or Java or so on and so forth. C#. Yeah. Okay. So I think that addresses at least my first pass. I have a sneaking suspicion that Dark will be able to come up with the help of maybe JB and some others, like something that some of the junior people can latch onto that will give them an entry point. I do want to be clear, guys, that my strong conviction is the rules of software development are undergoing a massive disruption. The way we create software is going to be fundamentally different than how we've done this in the past. And I think it's not exactly like what a lot of people are trying to push on you, because I think a lot of them are trying to make it like, oh, you're just going to use language models for all this stuff, and they're hard selling on the LMs, mostly because they just want to do the land, expand, demand model. And it's not exactly that, because we're not really paying the cost of the language models today. Not really. Unless you're like I am, where you're on the you're on the Anthropic Max plan, which is $200 a month, right? So I'm probably paying near, and truthfully, probably even that's less money than I'm actually costing in compute. But as we make more advances, like we get diff into these systems, I think diff as a substrate for many of the LM systems will reduce the compute overhead by upwards of 50%, right? This is why we're talking to Microsoft about this, is like they see that there's a massive, massive cost savings in their cloud if they have determinism for certain tasks like refactor. The ability to do massive refactoring with diff versus language models is like not even comparable. It's leaps and bounds better with something like diff than a language model by itself. Purely from the analysis of the code perspective, is diff can do analysis of the entire repository over its entire lifetime for the largest repos in the world. And, you know, we're talking about millions of lines of code, maybe tens of millions of lines of code, again, over the lifetime. So you take something like Kubernetes, which is 7 million lines of code, I think, in its current repo size, and then you do inference on that 100 times over its lifetime, you just have done 700 million lines of code of inference to understand how to do a proper refactor. That's just untenable with a language model. You're not going to do it. Even if it's an SLM, you need something that's significantly faster to be able to do that. And if you're going to do a massive refactor, you want, in my strong conviction, repository lifetime reasoning. You need to be able to reason about the whole lifetime, because you need to understand what they've done right, what they've done wrong, all of these things, and you can't see that from a single snapshot of the code that exists today. Again, why temporal reasoning is, I think, so important. So, that being said, I think that language models are here to stay. I think that we're going to see shifts, important shifts, to using small language models, probably an ensemble of them, and the compute costs need to come down significantly, but I think we're on our way. And then there's going to be other advances like diff and other deterministic stuff like the neurosymbolic verifiers that will work in tandem. It's more just the symbolic reasoners working in tandem with neural stuff, and that will add verification, and that will add essentially semantic reasoning, which is critical as these systems start to work with larger code bases or larger domains. But what is super clear to me is that I believe we will find a path forward with language models, because they're just too valuable to not utilize. But there's going to be some changes. But the way that we've done software in the past, that model, I believe, is gone. And it's just a question of if people in the software industry, wherever they are, have figured it out yet. And I think most people haven't. But some people have. I think the people that are living on the bleeding edge, like us on GTT, we've figured it out. We can see very clearly that no, language models are not perfect. Yeah, they have many issues, but they allow you to become a super coder or a super architect, as I like to say. For what I do is I'm not coding, I'm architecting, I'm orchestrating. And I got to be honest, I don't know that it bothers me that much that I'm not actually writing the code. I can just build things faster. And it does piss me off when the language models don't do what I'm asking them to do. That part is pretty annoying. But yeah. Oh, and also, one more thing, Kryn, that I want to mention before we move on to other topics, is it's critically important that you have the app that you're writing under strict source control. You've got to get it under source control and get it checked in and committed on a daily basis, right? Like this I have an auto commit continuous integration deployment kind of environment where I'm doing new versions every day, and every day all the code is being recommitted. And so if anything goes wrong in a catastrophic way, all I need to do is just roll back to yesterday's version, and I only lose at most a day's worth of work, right? And so this is really important. This is super, super important because the AIs are going to screw up your code. And if you cannot roll back to a known good state because you weren't actually putting it under proper repository control, you're gonna be screwed. And I've seen people make this mistake, is they're getting too comfortable with the AIs and they're like, I don't know that I really need to have this under source control. I think that it's not really going to be catastrophically bad. And so they don't put it under source control, and then it makes a mistake and it wipes out their code, and they're like, oh my gosh, I am cooked now. And you are cooked. You've got to get it into Git as soon as possible. And it's very easy with the advanced systems. You just have a GitHub account, you create a repository space for them, and then you just are dropping it in like on a daily basis. Like, let me see if I can bring up my GitHub so you guys can see this. And then I want to go back to the questions section because I think there's a bunch of questions I've missed. What happened with my music here? I've got like this one song I'm listening to on repeat this whole time. And guys, my vision is getting really bad. If you wonder why I'm doing this, these are bifocals or something, progressive, and the stuff that lets me see like up close is at the bottom, and so I have to I have to do the old man. Yeah, it's a fun little thing. Hold on, just give me 1 second. Why, Spotify? Spotify, come on. All right. Okay. Oh, yeah. Let me just see if I can bring up the repo so you guys can see. I mean, I know that all of you experts know what GitHub is, so I don't know that you need to see this, but okay, I guess I don't need to show this, but basically I have it all under source control, and I've got a few different branches that I'm working on and all of the stuff. But so if anything goes wrong, and maybe we'll get into this weekend on how to do proper sandboxing of the AI. In fact, that's probably something I should aim to do on Saturday, is go through the what's my sponsor again, guys? Who's my sponsor for this? Hostinger. I'll go through. I'm going to spend some time fiddling with Hostinger, and then I'll walk through how you can set up a virtual private server and then run Claude Code in that sandbox. And then if anything bad happens, you're going to be fine. Like, you don't have to worry about AI takeover. You don't have to worry about vibe corruption. None of that stuff. It's going to be, okay, you still have to worry about vibe corruption, but AI takeover, you can just cut the line. It's all in a sandbox environment. You are in a very secure space. It's almost impossible for your local machine to get hosed. And for those of you that are experts, you can do, I know you guys know what you're doing. You don't need to do this. But for newbies that are just getting kind of their feet under them, using something like Hostinger to ensure that if you accidentally click on the wrong thing, you accidentally install a rogue model, this protects you. So you can literally just wipe it, and you can have your code locked in your repo. And then if the AI goes rogue, you just say, okay, close down the server, wipe that machine, create a new instance, and start again. This is a really good way to protect yourself, in my opinion, from any of the problems that we've been talking about with AI. And again, for experts, I know probably many of you are like, yeah, I'm not going to do that. It's just too much work. And yeah, I mean, I don't do that. I have it sandboxed in my own way on my local machine, and I have it under pretty good control. But again, like, for people that don't know all the ins and outs and how to potentially do something, make a wrong click, so to speak. All right. Give me a couple of minutes. I'll be right back. You guys continue all the discussion. This is awesome. We have cleared the 3-hour mark. Yes. Oh, GB, I love that. Are you saying that you've been basically you've gone through the whole night? You just are no sleep? Uh, yeah, I gotta tell you, I actually need to end the stream here shortly because I actually have to get up at a somewhat reasonable hour tomorrow, and I need to like force myself to go to bed. But don't worry, we'll be able to continue. I also wanted to share, just amusingly, to give a demonstration of how clueless I am. When in one of the recent streams, someone was asking if I broadcast on the Discord about, oh, and we should drop the Discord constantly. Where is Discord? Uh, it's somewhere over here. What does Discord even look like? Okay, I found it. All right, the Discord, if you have been watching and enjoying this discussion, strongly recommend you check out our Discord. Join it. It's free. It's fun. It's super awesome. And I don't know. We have a lot of fun over there. And then also I have my YouTube membership where we're slowly getting to my goal of 100 people. I think we're at like 35 now. So we're more than a third of the way there. And I think it's $2 a month where you get the videos. And one of the big benefits of being a member is no ads. So the ads are gone, and then I try to drop the full stream, upgraded quality like this one, high definition video and audio. And once we get to over 100 members, I will start doing member-only videos where I can talk about some stuff that I just can't talk about in a non-walled way. So both of those are could be cool for you, potentially. But again, Discord doesn't cost anything. It's free. We like people that are nerds and that foster goodwill and want to learn. So if you fall in that category and you're enjoying this, please hop on over. And then the membership stuff, I would, I don't know, like people say you're, oh, yeah, I like user, if that's directed to me, like if people are saying negative things about me, I think that's just, a lot of people want to be haters because they're just haters, and that's to be expected, right? Like I get it. There's actually a lot of frauds out there, and so I would be skeptical too. But I think once people start to see that, you know, like if they actually did their homework specifically on me, then they would understand. But they're not doing that. They're just trying to, because I think there are, unfortunately, a lot of frauds and bad actors in AI. There are a lot of people that are just money grab for AI. And so it's easy to kind of put them in all the same box. But we're not in the same box, right? Exactly. Like this is one of the things that I've learned, JB. And JB is absolutely right. Like if no one hates you, you probably haven't done anything worth attention, right? It's going to be a natural. I learned this once I became the spokesperson for Intel. Is suddenly a whole bunch of people started to hate me. I was still the same person, I just now was a spokesperson for a really important company. And a similar thing happened when I finished my PhD and I was, Dr. Goju. A similar thing, I mean, there's even more people that hate me because of where I teach. And a lot of it is just, unfortunately, how to say this? A lot of people that haven't reached a certain level of emotional maturity will hate on people that have achieved things that they haven't. And yeah, yeah, right. Yeah, and the truth is, if they knew what, like, the anyway, yeah. But I think a lot of people, unfortunately, can take issue with others if those other people have been able to achieve things that they haven't, which is really unfortunate, right? Because there's a lot that we could learn from other people that have achieved things that we haven't, but that requires a lot of emotional maturity. It requires a lot of intellectual honesty. It requires a lot of introspection. And a lot of people don't have that, right? It is an evolved thing to look at someone and say, wow, I could learn something from you, rather than just saying, oh, this person is, a bad actor, or they don't know what they're talking about, or whatever. It's much easier to kind of, I think, take a negative view on the world because you stay in this safe space. But the problem with that is you limit your ability to grow significantly. And I don't subscribe to this philosophy. I love surrounding myself with people that know more than I know, and that want to push the envelope. And all the people that I work with that are like the superstars, they've all experienced similar things. They've gotten extreme amounts of hate because they're trying to do something different, or they're trying to draw attention to something that's important that people want to paint as something else. So it is actually par for course, user. And I'm totally fine with it, truthfully. I've experienced this many times. Like when I created Nautica, some of my players literally, I would get death threats from my own players on Nautica constantly, because I would change the game in a way that they didn't like, and I would nerf one of their classes or something, and they get really addicted to the game. And it's a strange thing to have like people that love the thing that you're building get so lost and confused about it that they will like threaten to murder the person that's created it. Like, that's not going to work out long term, bro. Like, if I'm not alive, then there will be no updates to the game. And so I get that you're angry. Anyway, so I love all the support, and I love that you're saying that, user. I will say that there was a period of time where it was a lot of negativity. And yeah, I mean, that stuff is, even if you have, like, I think as most startup founders know, when you start talking to VCs, 90% of the conversations are rejections. And getting rejected, I think some people, it's very easy to say, oh, you just thicken your skin and you toughen yourself to it and you just learn how to deal with it. It's very easy to say. It's very hard to do, especially when the rejections are happening at such extreme intervals, right? And so similarly, in social media, it can be overwhelming, I think, especially as you're starting to kind of break through and get recognized, that there's likely to be a large amount of like a groundswell of people that hate on you just because some people love you, right? It's usually like, it's almost like you're going to get a certain amount of people that hate you just because these other people love you. And it pisses them off that so many people like you. So they're going to hate you just because other people don't. It's very strange. Like, I don't subscribe to this philosophy at all, but I'm well aware of it. And so it doesn't actually affect me in any way. In many cases, what I try to do is help turn these people around. And the truth is, I've done this a number of times, is to help them see, like, no, we're trying to actually do good stuff here. We're like an actual community. And for those people that might have been a little bit just protective, a little bit skeptical, which I totally understand, actually, because there's so much fraud in AI. Those people, I think we've been able to turn around very quickly. And they've been great collaborators. In fact, many of the early fans of GTT started out initially being a little bit skeptical. And so, anyway, let me read through some of these comments and see if I can do a quick answer on some of them. And then I think we'll adjourn for tonight. We'll switch over to the Discord. And then we'll do deeper dives on things tomorrow. Okay. JB, yes. So 100% you can, your question about can't we solve context problem with diff? Yeah, 100% yes you can. But I think that the context problem is so big, it's hard to solve it completely with any single solution. And so what I'm trying to describe, because diff isn't generally available everywhere yet, although that's likely to change very soon, how to get around the context issues without diff. But once you have diff, yes, it will elide away many of the context problems through the pruning engine that we saw yesterday, those 3 phases. Oh, Kryn, sorry, we didn't go more on shiny hunters. Maybe we'll discuss this in a little more detail. The key thing for the shiny hunters is, my strong recommendation is, if you have a Canvas account, please make sure you change your password for any passwords that are identical of Canvas. Do not change your Canvas password though. That's going to be super bad, because if they still are hacked into the system, then now they have multiple passwords. But changing all the other passwords, especially making sure they're all different, is really important, because they may have hacked some of the secondary systems, but maybe not all of them. So each one of those ones, if you had like 10 accounts that all had the same password as your Canvas, change all 10 of those, but change all 10 to different passwords. All right. Yeah, Manon, yeah. I think that this is a very real thing, is if you can communicate effectively with the AIs and you can properly constrain them, you can improve their efficacy like tenfold. And if you don't do this, I think you will end up with slop and garbage, because that's the direction they will take you. But with those 3 guidelines, at least my experience has been, you can absolutely keep it on the rails and you can start producing production quality stuff. Like maybe in one of the future sessions, we'll look at the actual code. And I've been looking at the code, and the code doesn't suck. It did suck. It was really bad at first. But now after like many passes, it's maybe not as good as it would be if I wrote it, but it's writing 10 times, 20 times more code than I could write if I was writing it. So being at like 90% of the quality that I could probably produce and then doing 20x more work, I think that's pretty good. I think that's a pretty reasonable trade-off. Yeah, I love that you guys are deeply grokking on the difference between collab coding and vibe coding. Yeah, I don't know what this adapt one thing is, but let me add this to my list because I would like to know about it. Learn about adapt one. Awesome. Yeah, thanks for the tip, Giovanna. Mermaid diagrams? I don't know what we're talking about here, but I definitely love this thing. Yeah, Giovanna, as far as your AI teacher at the uni, there is a lot of stupidity that they're doing, and there's many reasons for this, but I think that we can course correct some of them in reasonable ways, and it will help make them better, notably better. Yeah, I agree, JB, that we need, and what's difficult is it's hard to know exactly when this is happening. I think we need to think about this more. Your point about when we've kind of exceeded the size of the context window. Yeah. Yeah, I need to think about this a little bit more. And eventually what I'm thinking will happen is this project will get itself to probably 100,000 lines of code. By the time it gets to about 100,000 lines of code, we'll have a real test to see if I've been able to collab code this in a way that it can still make highly productive changes without like massively diminished efficacy. Okay. Yeah. Yeah, that's interesting and awesome, Giovanna. I I'm reading Giovanna's comment about I've chosen not to use AI to code at all until I get to the point of post-grad on code itself. Yeah, there's a lot of merit to that approach. At the same time, yeah, I'm very conflicted on this because from my perspective, you know, I'm a like 25-year veteran in this, and so I kind of know how to code. And now I have a new thing that is helping me. But I do think that if you don't know anything about code and you just start using them, I'm seeing a very interesting pattern emerge, which is if you're a really expert software developer and you are already super awesome, you can be significantly more awesome with the right guidance to drive the AI. At the same time, if you don't know anything about software or you're kind of like pretty mid software engineer, then and you just vibe code it out, you can quickly get to complete garbage. And what's really interesting is that the AI model can be identical. It's the same AI model. So it's not the AI model that's the problem. It's the different people and the guidance that they give it, which goes back to how important it is on how the guidance of the AI makes a huge difference in their efficacy. It's literally like night and day. You know, going back to the ClickHouse code, that it's very clear that that is AI slop, and I can't believe that that's in their production repo. It's just stunning to me that that ever passed any kind of code review. Like, are they code reviewing at all? I mean, that never would have flown at Merle or on any of the teams that I'm on. Anyway. Yeah, Colin, I love that, right? I definitely get you on this. Having known you for a while, is that you want to make a meaningful contribution to the world. And you are, brother. Like, very seriously, you are. Being involved and helping with GTT because we are rallying the troops and we're creating a movement and things are happening, right? I mean, the evidence is right in front of us, right? Like, if all of these other numbers are ignored, the fact that we have 151 people on Discord that are excited about doing meaningful things and willing to give their time to promote our cause and support this mission, that's incredible. That in my mind, that is amazing. So it's happening. And Colin, you're a part of that, brother. Right? You helped and you continue to help with that. If I was you as early in my career as you are right now, I would be feeling really positive about my ability to contribute. Yeah, it can. Geneva, Giovanna, Giovanna. It absolutely can become real bad in the back end stuff. Yes, awesome. Coding does take a lot of practice. Like, goes back to the outliers thing, the 10,000 hour rule. Uh, and I know that that may be hard for people because you have something that can do all of it for you. But again, the ability to read code, not necessarily write code, but being able to read code is likely to be extremely helpful. It's kind of like our ability to read natural language, that you don't necessarily need to write news articles, but your ability to read news articles and synthesize that information to learn is super important. And if you can't read, the whole world of written language is closed off to you. And I kind of feel very similar about programming languages. Oh, that's sweet, Giovanna, that you're learning C. Uh, I'm more of a C++ snob, but C is definitely for a lot of the very advanced. There's a lot of hard things to learn there. Memory management, pointers, just, yeah, void pointers, handles, like some really inline assembly, just a lot of stuff. Mm. Yeah, I must have missed a little bit. Well, hold on. When I sell to non-technical business, it really requires me to be specific communication. Yeah, I agree with you, Dark. What's really interesting is, at least for me, it's much easier for me to explain things. And this is part of the reason why I only teach grad students. And I tend to do better with PhDs and postdocs and professors than I do with undergrads. Is I have to take additional translation steps to communicate ideas to people that have less knowledge, because I have at the tip of my tongue the things, but those things don't or won't make sense in their real form. So I have to distill them down to simpler and simpler and simpler ideas, and that requires significantly more mental energy. In other words, it's much harder for me to explain how things work, like with diff, to non-technical people than it is for technical people. Technical people, it's a breeze. Dude, you predicted the Canvas shit show on Wednesday. You're a prophet. I was there. You were like, this is a problem. And then just thought you should take a bow. You're vindicated. That's awesome. Yeah, I didn't actually even know that I was being crucified, but I suspect anytime I point out that this is going to be a real problem, people are going to be like, me, what is the saying? The boy who cried wolf. But it's mostly, again, a lot of it is just people not necessarily being deeply educated, and that's okay, right? They'll eventually figure it out. I had the same thing with the VCs and just general people with technology. I was trying to explain why language models they have major problems, and I had to deal with 4 years of people basically saying, and by the way, Goose, thanks, bro. I really appreciate that. Yeah. The Canvas passwords weren't leaked. Yeah, I mean, yeah. So, but yeah, it doesn't faze me at all. I think kind of what I've seen is the world will kind of catch up. And this is, by the way, and this isn't a flex. It's like, this is what happens when you're on the bleeding edge, is that you can see all the things more clearly because you work in the space of the future, right? Like as I say sometimes, I kind of live in the future. I don't really live in today. And so, and that's how we came up with like 3 pillars paper, is we were kind of like, well, here's where things are right now. It's kind of a mess, but it's going to move toward this, we think. And so we sketched that out, and it's really interesting to see this happening. And the same thing with language models is I could see that there were going to be all these problems, but I could see them only because I had been working in the space for a very long time. And when you have it, it's often much easier to see the issues than it is for people that are not experts. And so, yeah, so now a lot of the world has caught up on the problems with language models, and that's great because like I'm not about retribution or flexing on people or any of that stuff. I just want us to fix the stuff. and make it better so we can get to Mars. And so having more people on board and understanding is very helpful because now we can get to Mars. Yeah, this is very much exactly how I feel, uh, Giovanna. Critical thinking is very useful for a lot more than coding. Yeah, it's useful in, in my view, almost all aspects of life, and I have a very strong conviction that the better your critical reasoning skills, the better you will be able to interface with AIs. The problem is, I think, critical reasoning or the ability to think deeply is kind of like driving a car, where I think a lot of people believe they're experts at it. Like there's very few students that I've had when I tell them at the beginning of my machine programming course that one of the key things I'm going to do is teach you how to deeply reason about things. I get kind of this scoffed look of like, I already know how to deeply reason about things, Goju. Like, how dare you? But literally by the end of the course, I'll ask them, raise your hand if you can more deeply reason about things now than you could at the beginning of class. Like every hand goes up. And then I say, now remember this, right? Now remember how defiant you were about how you knew that your critical reasoning was all there and you didn't know certain things. You didn't know about weak claims and strong claims. You didn't know about degrees of separation. You didn't know about separating out the person from the idea. There's like many things that you just hadn't yet learned. So don't try very hard to not know the things that you don't know. It can really inhibit your growth. And it's really common when you talk about something like I've fallen victim to this myself. I thought I was a good writer. And in grad school, the biggest hurdle I had was how much I sucked at writing. It wasn't even my technical incompetence. It was the fact that I was a terrible writer. I didn't know how to communicate in written form, well, in spoken form as well. But written form in particular, I was explaining the wrong things. But the good news is I at least I think humbled myself and learned from people that did know, right? Like having humility and keeping yourself open to learning from others is such a wonderful thing you can do to just make you into a superhero. Yeah, I agree with this. Lauren, wait, hold on. What is Lauren talking about? Do you think the users will access Canvas anytime soon? Yeah, right. Like, I still don't know the full extent of the Canvas breach. And it's my speculation that the Canvas breach is like, obviously, Shiny Knights, or whatever their name is, they know how to hack the system. And I suspect one of the big problems that is happening with Canvas right now is they don't know how they're being hacked. That's my speculation. They know that they're being hacked, they just don't know how. And until they know how they're being hacked, they can't patch it. And if they can't patch it, they remain vulnerable and it is a standstill. Again, my hope is that some of the prominent security experts would get involved and figure out how this is happening, so then you could patch it and then the Canvas systems could come back online. But very intelligently, I have to say that part of the reason why I think Canvas is down, if it's still down, I haven't been following it at all today, is because they don't know. Like, oftentimes in triaging these critical breaches and these security vulnerabilities, the hardest part is figuring out how it's done. Once you understand how it's done, it's often super easy to fix the bug. As long as it's not a neural network, as long as it's not a language model. And thank goodness the software that runs the world today is not a language model, because if it was, we'd all be cooked. 100% Colin. Great observation. That's pretty much exactly right. That is one of the key pieces of the adaptation pillar. Once the adaptation pillar is fully integrated, it can become a closed loop system. And then it just iterates, and it does iteratively refines itself and makes itself better. And you now basically just express the intent, and then the system is making itself better and constructing new versions of itself for different ecosystems, like basically all the stuff. Okay, I think I've exhausted my ability to read, and I need a well-earned break. And I didn't get through all the comments. I'm sorry. I'm a bad person. I wonder. I wonder though. Hold on. Hold on. Let me try something. By the way, I love all these comments. This is so great. And I know that many of you are just talking amongst yourselves, and I think that's super awesome. Like, I literally love the fact that a lot of these comments, they're not even directed to me. They're just directed to you guys talking to each other. But I want to try something here. I want to try to drop this whole chat into my input system. Yeah, I want to continue. I've never tried to drop this much content into my system. I told it to create essentially an input buffer that is unbounded, and it resizes itself as it grows. So it starts off and it's not super big, but then, yeah. And so far so good, right, guys? Like, it's doing it. It is a little bit slow on the input here. Like, I think it's kind of cool that you can, look at that. Yes. Awesome. Cool. So now I can read all this even when I shut down the stream. And I need to figure out how to, hold on. Yeah. Awesome. And so what I may do is, just to rest my voice, is for any of the comments that I didn't address on the stream, if there's open questions and stuff, I may just drop it on the Discord. And then I can turn my brain off a little bit and just be more lazy, since I'm all about laziness, guys. Anyway, this has been super awesome. This has, I think, been one of our best streams. And yeah, Goose, thanks, brother. That's awesome. I actually thought at first when I looked over on Instagram and I saw the all caps, I was like, oh, somebody's real angry right now. Somebody's like, we've got another person that's really hating on us. And I was like, oh no, he's actually loving on us. This is awesome. So appreciate the love, Goose. Excellent, guys. So you are... Yeah, are you talking about the canvas attack? You guys are getting real deep. I love this. Never fully fill your glass. Yeah, man, this is like, there's some good stuff. Oh yeah, we're getting to Mars. Damn straight. Yeah, it's so hard, Dark. It's just so freaking hard, man. And I'm super lazy, bro. I need translators like you to translate, so you can talk to them and say, well, here's what he thinks, but he can't communicate this because it takes too much effort. Dark, you can teach all the undergrads, bro. Yeah, I know I'm a bad person, and I don't mean it like that. I just mean it's I don't have the intellectual capacity to make those jumps. And Kyle can, because he's infinitely more patient than me. Oh, yeah, man. That's what I'm going to get into. As soon as I turn this off, I'm going to stop talking for many hours. I'm just going to type, and it's going to be a thing of beauty. Uh, yeah, that's a great question, a user. And uh, yeah, I think maybe what we can do is take this to, yeah, it and totally. What some of this might be, it depends on your configuration, user, as Baz is probably going to get into, is if you're using the large language models that are in the cloud, your local hardware won't matter that much. Not really. I mean, it will a little bit, but now if you are running small language models and you're using things that are going to execute in a locally resident way, so like basically on your local computer, things like diff or small language models, then it's very helpful to have more powerful compute. And diff, for example, runs really effectively on CPUs, but small language models will often run more effectively on GPUs. So there's like there's a whole rabbit hole we can get into. But let's do that on the Discord, and I'll let you guys spearhead that while I get settled and stop talking, and then I'll circle back in half an hour or so. Excellent. Thanks, everybody. We're almost at the 4-hour mark where Insta's going to boot us anyway. So keep going and keep growing.